Good morning, everyone. Good morning. How are you all? Nanny? Audible? All clear? Bhanu? Fine, good. Tanushri? How are you all? Fine, good. So see, this is the last program which is run Go Fire. So already you have attended, I think, 2-3 lectures, means 2-3 rounds done. Physical chemistry part done. So now we have the time for inorganic part, inorganic and general. So there are 6-7 topics which we are going to do, out of which first 2 topics are like periodic, then chemical bonding, and then you can say P block. After this, DF coordination. Okay? And then at last we can have salt also. So we have to complete all these things, 6-7 topics we have to see. We will follow this sequence only in 3.5 hours. So for one chapter we are going to get half an hour. In this half an hour we will try to discuss NCERT salt example in text and some theoretical common points also. Theoretical common points, here only written repeated examples, means the point which are coming regularly. Acha, before this you also had marathon classes in which few examples of NCERT were also discussed. So we can repeat those examples also. And there are so many. There are so many. In this we have also included NCERT exercise questions. NCERT exercise questions. Now what? See, this lecture is going online. So if you want to make it fruitful and you want to understand the things, you will have to also cooperate. So whatever I am asking from here, those who are watching it from the campuses, you should reply to the questions. See, this is the last opportunity for you, I will say. Almost on, we are approaching towards the NEET exam. 4th you will have your NEET. So this is the last week only. So this is the last opportunity. So at this time at least you should follow what the teacher is saying. At this time at least you should follow full year what you have done. You know it very well. But at this time you should follow what teacher is saying. So if you will keep this lecture like this, ki sir is saying, I am listening very good, going, after half an hour, 1 hour, you will feel like he's saying continuously. But if you will try to reply, if you will try to reply to the questions, then it will be very easy for you and we can also pass this time very easily. I am not going to see you are saying it or not, but you should reply on your own. Take out your NCERT books also, because whatever questions we are keeping here, you should check from NCERT also. There are so many questions in this, around 60-70 questions are there. Okay. Then some questions we will give as homework also. See, suppose if there are 20 questions, I discuss all 20, you do nothing. This same thing we have done during the classes also. Okay. So now what? Suppose I tell you 10 and I give you 5. So if you are interested in studying, then you will find answer for the next 5 questions. कि अच्छा 10 तो he has told us. Now let's see these 5 questions. We will also do something so that you will develop some interest. So this is the last time for this academic year. We are telling you these points once again. So this is the last time I am saying you all these points again. So now you have to remember this anyhow. In half an hour we cannot take all the topics, we have taken few. ठीक है? So let's start. अच्छा, approximately half an hour for each chapter. So if you are feeling कि I want to attend only some chapter like DNF block, coordination, bonding, ठीक है? Then you can manage the time accordingly. Half an hour from here. ठीक है? Done? Let's start. And those who are sleeping, many of your friends might be sleeping also now. Many are eating in mess only. I have seen down. Okay, so wake up your friends. This is the last wake up call. They make the announcements, na? Last call for the passengers going from Vijayawada to Goa. Please approach to the boarding gates. Okay, so call them, wake up them, say them not to sleep, go and wash your face and be ready if you are interested for NEET. If you are interested for NEET, then be ready. This is the last opportunity. So let's start. चलो भाई, कहाँ गया? So see, many questions are easy. You will find that this one तो I know. ठीक है, this one you know. Next question it may happen you don't know. So that one you will learn. ठीक है? तो चलो बताओ. So let's start with the periodic table. So see what we are going to do in this. This is the sequence. Okay, so some basic things quickly we will do like 120. ठीक है ना? Everyone knows the configuration. Everyone knows the configuration of few elements. ठीक ना? Everyone know configuration of few elements. Then you know कि after z equals greater than 100, they are giving IUPAC nomenclature also. Very easy thing. Everyone is knowing un, bi, nil, tri, tetra. Tetra is there. So out of those 10, we are going to highlight something. What we are going to highlight? Like everyone remembers, sir, 0 is nil. 0 is nil. Un, bi, tri. 4. What is 4? We have a habit tetra. Tetra नहीं बोलेगा. What you will say? Quad. ठीक है ना? Quad. And then what? 5, pent, hex, 7. 7 what you will say? Hept. No. What you will say? Sept. ठीक है ना? And similarly 8, 9. 9 what you will say? In. So these 4, so this we are highlighting. See, there are 10. I have written only 4. So these we are last time highlighting. Ki these things you have to remember because many people writing here hept. You can remember like this. It is different from organic. What you write in organic, don't write it here. This is inorganic. Don't write it here. So now, if you want to write 120, 120, 1 means what? Un, bi, nil. Ium you add at last. So this is unbinilium. Unbinilium. Clear? I have also attached the things which are written in NCERT. You can check these numbers at least. Like you can check 108, 109, 104. Unnil quadium. Can you see it? Unnil quadium. Take out NCERT also. Same pages you have to see from NCERT also if you can do. Okay. Done. Next question you will see कि they are asking you tell me how you can prove कि fifth period has 18 elements. Fifth period has 18 elements. For this question, how to solve it? First of all, you should think about the periodic table. After studying this much, at least you know the basic idea about the periodic table. कि हाँ ठीक है, first seven periods are there, ठीक है. Then from fourth period full 18 elements. Fifth period 18 elements, ठीक है ना. 6, 7. So can you tell me how many elements are present in 6th and 7th? So you can say 4th period to sir I know 18 and 5th period also I know that is 18. Then what about 6th and 7th? Batao. Now you should say it. Those who are watching from the campus, now you should try to say it. Ki how many elements are there in 6th and 7th period? ठीक है ना? You can say sir 5, 10, 12, whatever you want. See, this is a solved example. Similar question you are having in the exercise also. Similar question, if you are not able to see it, on the basis of quantum number, justify 6th period element have 32 electrons. So now we know that these are having 32, 32. These are having 32, 32. How you will know this? Ki sir, 18 to normal I am seeing. And what? 14 F electrons are also there. So that's why 14 plus 18, 32. The point is how to explain this. Sir, question mein they are asking ki explain from quantum number. How we will explain from quantum number? So you will see the solution. अब देखो इधर solution एक बार. In the solution they will write कि in 5th period we fill 5s, 4d, 5p like this. Clear? What they are saying? 5s, 4d, 5p. How you will get these numbers? कैसे पता चलेगा कि we have to fill these things? So there is a basic point. Everyone knows Euler's diagram. See, every period starts from s orbital. Like 4th period starts from 4s, 5th period start from 5s, 6th period start from 6s, 7th period start from 7s. 4s, 4p, 4d, 5s, 5p, 5d, 6s, 6p, 6d. अरे सर f is also there. चलो ठीक है भाई, लिख दो f, लिख दिया f, 7s, 7p and so on. Now you have done like this also na? Keep 5s. After 5s, what you will fill? 4d. After 4d, what you will fill? 5p. Sir, after 5p, 6s. Arre, but when you are writing 6s, then though you have started what? 6th period. So you have to check the orbitals from 5s till 5p before 6s. So which orbitals you are filling? 5s, 4d and 5p. How many electrons here? 2 electron, 10 electron, 6 electron. Total how many? 18. Video got stuck. Check your connections. So this is about 5th period. 18 electron 5th period. Can you tell me now, according to this, in 6th period, which is the next question? देख लो, this is the question 3.4. 3.4 next question. Can you tell here कि which orbitals will be filled in 6th period? Which orbitals will be filled in 6th period? बताओ. After seeing this diagram, can you tell offline students, campus वाला, बताओ भाई, 6th period में which orbitals you will fill? There is different fill, feel. ठीक है ना? You have to take feeling of this and you have to fill the orbitals. ठीक है? अब आ जाओ next. So you will say simple sir, 6th period. So we will start from 6s. Very good. 6s. Then what sir? Next 4f, 5d, 6p. Stop. Because after this, who is coming? 7s. 7s means what? 7th period. So which orbitals you are filling? Jaldi batao kya kya fill kiya? Sir, I have filled 6s. I have filled what? 4f. I have filled what? 5d. I have filled what? 6p. Batao how many electrons now? See, this is extra. 14 electrons. This is extra. 14 electrons. 2 from here. 10 from here, 6 from here, total how much? 18 plus 14, 32. So this is the way. So if they ask you ki which orbitals are filled in a period, you can start like this. Clear? ठीक है. You can start from, like fourth period they will say, start from 4s before 5s. Fill till before 5s. Clear? Okay. Come to the next part. They are again saying about 117 and 120. See, next few questions. They are asking you location of 117, 120. And next NCERT question, they will ask you the location of 114. They will ask you the location of 114, 117, 120, 114. Now see, prediction of element location. While teaching, we have taught you this in half an hour. But now I will highlight. Now, once you rejoin, check it, you will get the video. Here to working, everything good. Now see here. So they are asking you location ki bhai ye periodic table mein kidhar hai? Where are these elements in the periodic table? So now at least see whatever we are teaching today, this is the last or the minimum requirement which everyone should know. Minimum requirement which everyone should know, must know, if you are serious for NEET exam. Now also if you are putting your head on the bench and sleeping and waiting for lunch, ki lunch to today they will give us nice, then don't waste your money for going to the centers also. Save that also and eat. So what we are saying here, this is the minimum requirement. Means what? Everyone should know, bhai, F block kidhar se kidhar start hota. Everyone should know F block lies from where to where. So everyone knows ki sir, there is 4F series, there is 5F series, cerium till lutetium, sir, this is 58, this is 71, this is thorium, sir, what is the atomic number? 90. You know thorium exception, सबको पता है कि नहीं भाई? 5s, outermost f orbital 0. What is this? Lawrencium. Lawrencium how much? 103. So if anything they ask you in this lies in this one 6th period, this one 7th period. Can you tell me full F block lies in which group? Full F block lies in which group? Jaldi bolo. Full F block lies in which group? You will say, sir, 3rd group. Full F block lies in which group? 3rd group. Very good. So, can you see any element in this region? No, sir. No element is there in F block. Now, how to do? Don't worry. There is one more shortcut. From 103 till 118, last 2 digits are their group number. Last 2 digits are their group number. Last 2 digits are their group number. So simple. Now see how simple this question is. Can you tell me what is the group number of 117? Jaldi bolo. Group number of 117. Sir, 17. Group number of 114. Sir, 14. Done. Sir, what about 120? Arey 120, you think like this. 118 finished here, 18th group. Then you will start new 19, 20. So this is what? Alkaline earth metal. 118 organism. Period khatam. Then come to the next period. Imaginary. These are imaginary. So 120, second group. So what you have to remember? You have to remember this. Third group, fourth group. So from this question, I will say you F block configuration means starting ending, F block starting ending, and 103 to 118. Anything comes, we know the group number at least. We know the group number at least. Aja bhai. Next, metallic character and all. Now see, few questions are there based on metallic character, size, ionization energy and all. So I will tell you some theoretical part quickly, then we can do it. Like see, everyone knows this point कि भाई radius निकालने का है. 3-4 types of radius are there. Van der Waals. If you compare these radius for any atom, then which one is the biggest radius? Van der Waals. Then you can say what? Sir, metallic in middle. And who is the smallest one? बोलो कौन है सबसे छोटा? ठीक है, like sodium I have taken. For sodium I am calculating van der Waals radius, metallic radius, covalent तो चलो not defined, but चलो ठीक है. Means for any element if we are comparing all these things, then covalent radius is the smallest. Then next point we know. बताओ, what do you conclude from this point? What do you conclude from this point? What do you conclude from this point? Batao. Anion are bigger than parent atom. Cation are smaller than parent atom. If you increase positive charge, size decreases. If you increase negative charge, size increases. So you can remember this. Anion, parent atom, cation. The next point you can remember isoelectronic. Isoelectronic species में बताओ how you tell the radius. Isoelectronic में do you remember? Now if you don't remember, you can see your notes. Isoelectronic species coming again and again in exams. So everyone should know that radius is inversely proportional to atomic number. NCERT question, we will see it. Radius is inversely proportional to atomic number. Like if I give you N3 minus O2 minus F minus Na plus Mg2 plus Al3 plus bolo. Are these isoelectronic or not? Yes sir. How many electron? 10 electron. Batao, who is biggest? So from here, whose atomic number is less, radius is more. Whose atomic number is less? N. That means its radius is more. Aluminium atomic number maximum, radius less. See, I'm again telling you, whatever points we are writing today, at least you should know these things. At least you should know these things. Next, few exceptions are there. Like what exceptions you have to study? You have to study the exception of boron, aluminium, gallium, indium, thallium. Everyone knows that down the group size increases. But here we have problem. Gallium is smaller than aluminium. Gallium is smaller than aluminium. Gallium is smaller than aluminium. Then next one, you should also see lanthanoid contraction. Lanthanoid contraction. Batao, whose sizes become same? Screen video stuck. What happens? It automatically becomes normal after some time. it is stuck, then automatically it becomes normal. From my side it is coming very good. Check your connection only problem, but many 2-3 people are saying. Acha, same lecture is there on YouTube also. So you can check from there also. ठीक है? Lanthanoid contraction whose sizes become same? बोलो. 4D and 5D series element sizes become same. Like what? Zirconium, hafnium size similar. Niobium, tantalum, molybdenum, tungsten. Now, these sizes are similar. So we'll come to this point once again later on. Question is there. ठीक है? तो इतना कम से कम देख लेना. In ionization energy, what you should remember? बताओ. Ionization energy. Normal trend तो everyone should know. Ionization energy, electron affinity, electronegativity. Trend is same. कि in a period ionization energy increases, down the group ionization energy decreases. Same thing is for all. EA also same order, EN also same order. ठीक है? So let's see the exceptions of ionization energy. बताओ, याद है एक्सेप्शन ऑफ आयनाइजेशन एनर्जी क्या क्या है? बोलो. So 3-4 are there. Very 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 important. Very 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 important. ठीक है ना? Group 2 and group 13. So normally in a period ionization energy increases. It should be like this. Bolo, it should be like this. But problem. What is the problem? Ki group 2 is more than 13. Means what? Beryllium, boron. Who is more? Beryllium. Then magnesium, aluminium. Who is more? Magnesium. This point only we will use here. This point only we will use here. This point only we will use here. One exception. Now see, many people remember the exceptions, but they are not able to apply. They are not able to apply. So practice the questions before only. ठीक है? So group 2-13 we are knowing. Next what you are knowing बताओ. You can say कि sir 15-16 also we are knowing. कि generally 16 should be more. In a period ionization energy increases. But who is more? 15. Why? Sir, half filled. Everyone knows this point. So nitrogen is more than. बोलो यहाँ क्या लिखे? Nitrogen is more than oxygen. Phosphorus is more than sulfur. These things are there. Then you have to also remember group 13. Group 13, boron, aluminium, gallium, indium, thallium. Down the group, ionization energy decreases. But here we have some exception. Thallium, you have to remember, like you have remembered from W shape. Good. Anyhow you remember. I remember like this, कि thallium I will put here, aluminium I will put down. So finally the order is boron, thallium, gallium, aluminium and indium. Now it is correct कि down the group ionization energy decreases. So boron maximum, thallium second. Gallium is more than aluminium. Gallium is more than aluminium. Gallium is more than aluminium. Last, group 14. Group 14 में what you have to change? Carbon, silicon, germanium, tin, lead. Change the last two. Change the last two. Change the last two. Clear? देख लो. Are you able to remember कि these things were taught to you before also? These things were taught to you before also. Do you remember? So now let's see this question. So what they are saying in this question, बताओ क्या बोला इस question में कि we are having 3-4 elements they have written कि we are having sodium, magnesium and silicon. These 3 things they have given. And predict whether first ionization energy of aluminium. Where is aluminium? चलो ठीक है. This is the normal order कि sodium, magnesium, aluminium, silicon. अब बताओ, can you tell me what should be the correct order? This is group 1, this is 2, this is 13, this is 14. बोलो. Normally in a period ionization energy increases, so it should be like this. देखो. Normally in a period ionization energy increases, so it should be like this. But now only I have told you exception कि अरे group 2 and 13 you have to change. Then who is more? Aluminium you put here. Only you have to change this group. Don't change. 2, 13, 15, 16. 2, 13, 15, 16. This only you have to change. So this is aluminium and this is magnesium. Ab dekho, check the values. What data they have given for sodium 496. Okay. And for sodium 496 and for magnesium they have given 737 and for silicon 786. तो बताओ, they are asking कि aluminium will be close to 575 or 760. See, 760 is here na and 575 is here. तो बताओ, it will be closer to what? Aluminium should be less than magnesium. So this value. Correct? So based on exception, NCERT. Based on exception, NCERT. Now see, same question in NCERT once again. Same question in NCERT once again. So lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. All these are in a period. Ionization energy increases. But what is the mistake now? बोलो क्या क्या चेंज करेगा? What you should change in this order? What you should change? Sir, you will clearly see. Now remember which group you have to change. Sir, beryllium, boron, change. 13 is less than 2. So boron, beryllium. Only these 2 groups you have to swap. Next, nitrogen, oxygen, change. Nitrogen is more than oxygen. So oxygen is less than nitrogen also, fluorine also. Same thing they are asking here. Same thing they are asking here. देखा? So 213 change. 15, 16 change. Rest all same. So at least everyone can remember this. चलो आ जाओ. See this point now. See this point. 1-2 people here saying video is stuck. चलो done. आ जाओ. Sodium, magnesium, you know. You will say, sir, sodium here, magnesium here. What is the configuration? बताओ का sodium का 3s1. 2p6 3s1 here 2p6 3s2 in a period increases. So this is the order of ionization energy 1. We know कि magnesium is more than sodium. Normal trend. Magnesium more than sodium. But when you will remove 1 electron, it will become magnesium plus. What will be the configuration now? 2p6 3s1. If you remove 1 electron from here, it will become sodium plus. What will be the configuration now? 2p6. Bolo, correct or not? After removing 1 electron, this will be the configuration or not? After removing 1 electron, this will be the configuration or not? Yes. Now can you see कि भाई sodium became noble gas, stable configuration. So second ionization energy of sodium is more than magnesium. पहली बार everything normal, first time everything normal, magnesium more, but second time sodium becomes neon, 2p6. Sodium is more, and this is NCERT. So everyone should remember. यही आ गया मान लो नीट में तो you are taking things lightly. कह रहे these things तो we know, who will study. मान लो this question only comes in the NEET, and if you have just remember this thing कि अच्छा this thing was taught, 4 marks, very easy, 4 marks. See, this one I have told you, ionization. देखो बोरोन, बोरोन के बाद क्या बोला, देखो इधर 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 इधर, ग्रुप 13, मैच इट, मैच मैच. बोरोन के बाद थैलियम, करेक्ट. नाउ आल्सो स्टक, डू समथिंग. Online people, those who are saying video is stuck, they can check periodic table 3.19 question. So after boron, thallium. देखो indium minimum, gallium is more than aluminium, 2 units only, but they will ask. समझ में आ गया, खत्म. So that's all. आ जाओ next. हाँ, okay. Now see next question, next 3 questions. Now see, you can see how the things are there. This question is in periodic table. अच्छा, चलो we will wait for 2-3 minutes. They are connecting it in the online classes. Some problem was there. Those who are in the campus, boys, girls, long term, seniors, breakfast done? What was there in the breakfast? You say it from there only, I will hear it. Breakfast only your favorite, na? So we have to study so many chapters today. Keep interacting, then only it will be easier. Keep interacting, then only it will be easier. Same question you see, acha, this question. You see, this question I will not forget. Sodium, magnesium, first ionization energy, second ionization energy. I will never forget. Now come to the next point. See, this all 3 questions. This is in periodic table, and this question is in P block. Both are based on same point. Which point? Electron affinity. You know what you know, electron gain enthalpy values we are knowing. Whose electron gain enthalpy maximum? You will say, sir, chlorine minus 349 approximately. Fluorine what? Fluorine around minus 328. So here there is a very big exception. Everyone remember? Okay, sir, this is second period, this is third period, nitrogen, oxygen, fluorine, phosphorus, sulfur, chlorine. Generally, electron affinity decreases down the group. Electron affinity decreases down the group. Then who should be maximum? You will say, sir, fluorine should be maximum. Fluorine should be maximum, but what is the change here? Ki array, third period is more than second period. Third period is more than second period. So this order is wrong. So fluorine, chlorine, bromine, iodine. Here you have to make one change. What change you have to make? Batao. Chlorine and fluorine. Chlorine is more than fluorine. Chlorine highest electron gain enthalpy, or you can say electron affinity. Chlorine, Cl can take electron easily. Same thing here. Who is more? Sulfur. Who is more? Phosphorus. In fact, in this, oxygen is minimum. Sulfur, selenium, tellurium, polonium, last oxygen. Last oxygen. Last oxygen. देख लो, these two things everyone should remember, these two things very 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 important. These two things everyone should remember: chlorine, fluorine, bromine, iodine, sulfur, selenium, tellurium, polonium, and then there is oxygen. Oxygen is last. So these all question can be solved on this basis. There is one more point, कि when you add the first electron, electron gain enthalpy value can be positive or negative. Like for beryllium, magnesium, nitrogen, and noble gas, electron gain enthalpy 1 is what? Positive. So first electron gain enthalpy can be anything. First electron gain enthalpy can be anything, positive or negative. ठीक है? First electron gain enthalpy can be anything, positive or negative. It can be positive or negative. For these elements it is positive, for oxygen it is negative. But from second onwards, electron gain enthalpy is always, batao, fill in the blanks, is always positive. They ask you in the question, which of the following energy is absorbed, and one of the option is this. So this only they are writing here, first electron gain enthalpy to negative, oxygen second gain electron enthalpy positive, and overall net is positive. Then many more things they have asked there. Leave it. But what point we have to remember, कि first electron gain enthalpy can be, bolo. First electron gain enthalpy can be, bolo. This time NEET question will come from here only. Electron gain enthalpy, bolo. First electron gain enthalpy can be positive or negative. But from second onwards, it is always positive. Means first electron someone wants to take, someone don't wants to take. Someone wants to take, someone don't take. But second electron no one wants to take. Second electron no one want. First electron dicey. Yes sir, no sir, yes sir, no sir. From second onwards, no sir, completely no. Understood this point or not? Very 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 important. बोलो भाई, अब बता सकता है? Can you tell here quickly? Chlorine, fluorine, whose electron gain enthalpy, whose electron affinity more? Chlorine. Correct ना? अच्छा, oxygen, fluorine. अरे oxygen minimum in its group, fluorine is more only. You can say fluorine second max, chlorine max, fluorine second max. Chlorine max, fluorine second max. देखो, again this question based on this point only. Whenever this type of question comes, you write it in a periodic table representation. Sir, this is phosphorus, this is sulfur. Sir, कैसे लिखा? Sir, this is phosphorus, this is sulfur, this is chlorine, this is fluorine. See, this is the location in periodic table. This is 15, 16, 17. अब बताओ, most negative means highest electron affinity. Who has highest electron affinity? Chlorine. In a period, electron affinity increases. Then who is minimum? Phosphorus. देख लो भाई, matched or not? Yes. Chlorine maximum, phosphorus minimum. In a period, electron affinity increases. In a period, electron affinity increases. Okay? So you can represent like this. Oxygen minimum in its group. Done? Okay. So now come to this question. This question again already discussed. They are asking about oxidation state and covalency. See, oxidation state everyone knows. Oxidation state everyone knows. You have studied this in redox chapter. You have studied this in coordination compound, and we know also कि भाई aluminium तो single oxidation state Al3 plus. You can calculate it from here. Aluminium X minus 1, pani what? 0. Neutral ligand equals to +2. X is your +3. Oxidation state very easy. Covalency. What is covalency, bhai? Number of covalent bond. Number of covalent bond. Batao. Here aluminium forming how many sigma bonds? Bolo. Aluminium forming how many sigma bonds? Aluminium forming how many sigma bonds? You will say, sir, इधर थोड़ा change करने का. This is 5. You will say, sir, total 6. 1 with chlorine and 5 with water. Total 6. Covalency, you can simply think how many sigma bonds an element can make. ठीक है? Covalency, covalent bond. Sigma bond here we can check in this, but generally covalency you can say covalent bond. Covalency means what? Total covalent bond. Like if I write phosphorus here, phosphate. What is the covalency of phosphorus? 5. 5 covalent bonds it is making. Coordination number sigma bond, no pi bond. Coordination number is there. देखो भाई, covalency. Total covalent bond formed by an atom. What is coordination number? Sigma bond. You can say total sigma bond formed by an atom. Formed by an atom. Clear? देखो ये है. So here covalency, coordination number both same. Here covalency, coordination number both same. Clear? This is the covalency you can say. This is the covalency. Coordination number बोलेगा तो क्या बोलेगा? 4. How many sigma bonds? 4. Covalency, number of covalent bond. You remember that point? कि second period element cannot expand its second period element cannot make more than 4 bonds, cannot expand their covalency. That's why they ask you question in P block. You will find कि अरे nitrogen pentahalides not possible, PF5 possible, but nitrogen pentahalide not possible because nitrogen cannot form 5 bonds. Second period element maximum 4 bonds. Second period element maximum 4 bonds. So there are 8 electrons. They don't have capacity. So covalency you can remember like this. Like how many friends you are having. Total count and tell. How many friends you are having, that is your covalency. How many friends you are having, that is your covalency. That many bonds you are making. Okay, that is covalency. Simple. Covalency means covalent bond, total sigma plus pi. Covalency means covalent bonds, sigma pi all. Covalency means covalent bond. नाम से पता चल रहा है ना? Covalency means covalent bond. Clear? So I think this is all about periodic table. This is all about periodic table. So first chapter we have completed. Now we'll go towards chemical bonding. Chemical bonding, you will have to see some shapes. Some shapes you will have to remember, like CO. CO diagram everyone knows कि sir bond order is 3. Bond order is 3 plus minus. There is coordinate bond also. Oxygen giving electron to carbon. Carbonate diagram you can remember. CO3 2 minus. They will ask you, how many resonating structure? you can say 3 resonating structure. How you can make 3 resonating structure? 1 double bond here, next time here, next time here. 3 possibilities, 3 possibilities, 3 resonating structure. Okay? Next, you can remember O3 diagram. O3 diagram like this. O3 diagram like this. O3 diagram. O3 also having how many resonating structures you can say? Same thing. 1 time double bond here, 1 time double bond here, 2 resonating structure. Bolo. Do you remember all these points or not? See, by normal logic, so you should know all these points because after few days only you have NEET exam and you have prepared very well. So you should already know these points. So if we are taking these classes in offline, I will ask you all these questions and you should reply. Before this, all the teachers have told you, see the solved example of NCERT, do the exercise. So we assume that you are good students, highly dedicated towards your exam and you have done all these things. So you are already knowing. नहीं बताओ ऐसा है क्या? Acha, you know this thing ki in ozone you can also show this plus minus by a coordinate bond. Then also same thing, na? 2 resonating structure. 1 time coordinate bond here, 1 time coordinate bond here. See, coordinate bond is optional. Coordinate bond is optional unless they ask you. Don't tell it. If they ask directly, this is having coordinate bond or not, then only tell yes. Otherwise, don't use the word only. Don't use the word. Don't use it only. Okay? So 2 resonating structure we can see clearly. As our next point, CO2 very important. How many resonating structures of CO2? Bolo. How many resonating structures of CO2? How many resonating structures of CO2? How many resonating structures of CO2? 3, 3, 3. 9, 3. 3 resonating structures are there. Sir, how? I have to seen only one. See, this is the most stable one. We make this only. So that's why everyone have seen this. Next time what you can make? One side 3, one side 1. This side 3, that side 1. Where 1, there you can put 1 negative charge. Where 3 bonds, there you can put positive charge. Okay? So 3 resonating structures. 3 resonating structures. Now they have written all these things here. The main point you will see, sir, here to something like bond length written. You are not telling bond length. You are telling me resonating structure. ठीक है. First you listen about resonating structure. 3 are there. Now I will ask you. कि अरे carbon oxygen bond length. Can you comment? Can you comment on carbon oxygen bond length? CO bond length. So according to the data given here, what they are writing, कि CO bond length lies between triple bond and double bond. Triple bond smallest, na? So they have given the data 110 picometer. And double bond, it is 121 picometer. CO2 is in middle, 115 picometer. तो अगर तुमसे बोलेगा कि CO2 में CO बॉन्ड लेंथ बताओ, CO2 में CO बॉन्ड लेंथ बताओ, तो क्या बोलेगा? What you will say? कि सर CO बॉन्ड लेंथ lies between double bond and triple bond. Double bond and triple bond. I am quoting the data also so that you can remember easily. CO bond in CO2. CO bond in CO2. CO bond in CO2 lies between bolo double and triple. 110, 121, बीच में 115. Clear? देख लो. So few diagrams I have told you like ozone, carbonate, and CO. अच्छा, one more point is there कि they ask is are bond length same or different? Bond length same or different? See, generally whatever questions are in chemical bonding na, their equivalent resonating structures are there in most of the case. So bond length are same. So you can say like this कि if resonating structures bond length is asked based on chemical bonding, then bond lengths are same. Carbonate, phosphate, sulfate, ozone, CO2, ठीक है ना? So all these case there is only one type of bond length. ठीक है? So this is means not exactly correct thing, but if it is in chemical bonding you can remember like this. मान लो क्वेश्चन आ गया कि phosphate में बताओ how many types of PO bonds are there. Then what? If you will remember this line, phosphate तो they have told in bonding chapter, so one type sir. Carbonate bonding chapter, one time sir. ठीक है ना? So like this you can tell. Only one type of bond length. Only one type of bond length. Clear? So this is all about this. तो बताओ CO2 bond length lies between. आ जाओ. अब लेट्स टॉक अबाउट डाइपोल मोमेंट. ये क्वेश्चन याद है तुमको? NH3 NF3 इज दिस इंपॉर्टेंट और नॉट? बोलो डाइपोल मोमेंट. व्हाट डू यू मीन बाय डाइपोल मोमेंट? सर डाइपोल तो आई हैव स्टडीड इन फिजिक्स आल्सो, वेरी इजी. म्यू इज इक्वल्स टू QD, वेक्टर क्वांटिटी. ठीक है, दोस थिंग्स कीप इन फिजिक्स. अब क्या करेगा इधर? सर सिंबल. सर सी हियर HCl, this is more electronegative, delta minus, this is less electronegative, delta plus. Show it like this. Show. You know in chemistry and physics signs are different. Physics में ऐसे मारता sign, ठीक है ना? Chemistry shows us flow of electron. Chemistry shows us flow of electron. Electron is going like this. This is chemistry. Chemistry there is one dash also. Easy way to remember chemistry dash. See, this is looking like plus na, plus 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 plus. Opposite is physics. हो गया? Remember the units also. D by relation, coulomb meter relation you will have to see. तो चलो जल्दी से quick we write some orders first. Like you remember this order? कौन सा order बताओ? CH3Cl, CH2Cl2, CHCl3, CCl4. Dipole moment order. CCl4 in fact 0. HF, HCl, HBr, HI. Based on electronegativity. Based on electronegativity. Simple. Then something, this one you remember? CH3F, CH3Cl, CH3Br, CH3I. बताओ. Now what happens? I have said based on electronegativity. Based on electronegativity. Based on En. So people apply the same point here also. Okay, sir, like this I will do then. But we know this is something exceptional. But we know this is something exceptional. Who is more? Bolo. Chloride is more than fluoride. Chloride is more than fluoride. CH3Cl is more than CH3F. Very, 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 very important. And next point, this also we'll have to learn. Pani, then HF, then NH3, then NF3, then BF3. BF3 the symmetrical structure 0. We have said whichever is having symmetrical structure, dipole moment is 0. Dipole moment non-zero means what? You can say it is non-polar. Dipole moment question can come this year in NEET. Dipole moment question can come this year in NEET. ठीक है ना? So see the important points. This is from data of NCERT. Data NCERT. This we can explain, which they are asking in this question also. But how can you explain it? They are asking this one in the question also. See, इधर ही तो देखो. All things started from here only. NH3, NF3. Bolo, who is more? NH3, sir, you have already told. But how? How this is more? Diagram drawn in NCERT, ki sir, NH3 looks like this. NF3 also looks like this. Trigonal pyramidal. Lone pair movement is always towards itself. Here also same. But the next part is different. N and H, who is more electronegative? N. So all going up. Net dipole moment more. Acha, here what is the difference then? Arey sir, here fluorine more electronegative. Down. Then both are cancelling each other, sir. I will write 0. Nahi bhai, 0 nahi. They are opposing each other. Both are not same na, up down. Are they same? No. They are opposing each other. So net dipole moment is less. Net dipole moment is less, but it is not 0. It is not 0. So you will say here lone pair and bonds, both same side. Here opposite side. That's why less. One question came in your paper. See, there are two types of question. One question is bond is polar. Polar bond. One part is polar bond. Other part is polar molecule. These two things are not same. Both are not same. Polar bond means you can simply say En difference should be there. Like I will say HCl. En difference is there, na? Then polar bond. If you will say Cl2, no En difference, non-polar bond. Okay, so this is just about the bond. This is about molecule overall. Like I will give you CCl for example. Polar bonds are there or not? Yes. Polar bonds there or not? Yes. Delta minus, delta plus, polar bonds are there. Polar bonds are there. But overall shape is tetrahedral. Mu is equals to 0. The molecule is non-polar molecule. Dekho, try to digest this. Polar bond is different. Polar molecule is different. Polar molecule means overall. Like you attempted suppose physics, chemistry, bio. You get 100 marks in physics. Okay. And you got 150 marks in chemistry. Wow. So nice. 250 marks total. Na? Batao? 250 marks total. Good marks, you can say. Na? Means good only we will say. This is not the best part. But suppose bio you got 0 now. Now your marks is bad. Overall your marks is very bad. 250 only. But physics, chemistry it is very good. So overall things are different. Particular things are different. So bond is polar means I will check one bond. Polar. Molecule polarity means overall. Polar bond, polar bond, polar bond, polar bond. But all are cancelling each other, net 0. Understood? Okay. Come to the next part. Next part, this question is based on hybridization. We know that BF3 is there, NH3 is there. And BF3 dot NH3 they have written. Dot means what? Dot means this, that nitrogen has shared its lone pair by coordinate bond. Nitrogen has shared its lone pair by coordinate bond. So now they are asking hybridization in each case. See, chemical bonding, hybridization and shape. Hybridization and whisper theory shape. Everyone should do it. That is the means now we cannot explain it like this we find hybridization. Now also if I am explaining how to find hybridization, after 3 days, 4 days, 5 days, there will be NEET exam. Do you think is it good? No, na. So everyone should know at least hybridization telling, shape telling. Shape and hybridization. So see, this is AB3 type of molecule, no lone pair. This is AB3L. So AB3 means sp2 trigonal planar. This is AB3L. Steric number 4 means sp3, but the shape will be trigonal pyramidal. One lone pair is there, na? Okay. Now see here. Focus here. Boron, how many bonds are there with boron now? Now boron has 4 bonds. 3 normal, 1 from nitrogen. 3 normal, 1 from nitrogen. 4 bonds. So this is tetrahedral sp3. Nitrogen, lone pair was there. Now it has shared. So lone pair is converted into a bond. So now this is AB4. Hybridization is still sp3. Shape changed. So in this question, now suppose you don't know anything, at least know this question. So now you tell me, is hybridization of boron changed? Bolo. Is hybridization of boron changing? Yes. Is shape of boron changing? Yes. Dekh lo. But what about nitrogen? Nitrogen hybridization same, but shape is different. Clear with this? So this is the meaning. There you go. Next question, they are asking PCl5. Everyone knows PCl5. Sir, PCl5, AB5. PCl5 is what? AB5. AB5, sir, means sp3d. What is the shape? TBP, trigonal bipyramidal. In trigonal bipyramidal, there are 2 types of bond. One is equatorial bond, other is axial bond. Batao which is equatorial? This one is equatorial. This one is axial. See, now I will suggest you something. मान लो, suppose you don't know hybridization, sir. I don't know about the features also. What is SP? अच्छा, SP hybridization is also known as diagonal hybridization. Everyone knowing. Suppose you don't know about octahedral and all. The most important shape is TBP. Maximum variation we see here only. Like in this first point, they will ask you, "Batao bhai, all the bonds are same." You will say no. Axial bond is longer than equatorial bond. Axial bond is longer than equatorial bond. Why? They will say, sir, see, equatorial angle is 120. Equatorial angle is 120. More angle, sir. Far. 120, 120, 120. Far. Repulsion is less. But here, sir, axial bond angle only 90 degree. So repulsion is more. That's why bond length will increase. So see, this is the line of NCERT written here. As the axial bonds suffer more repulsion. Why? Less angle. The equatorial bonds, therefore axial bonds have been found slightly longer. That's why weaker. PCl5 is more reactive. Is it clear to everyone? एक बार जल्दी से पढ़ लो. देख लो भाई, देख लो जल्दी. Clear? अच्छा, can you tell me कि lone pair are kept on which position? Equatorial or axial? In TBP, lone pair is kept on equatorial or axial? बताओ. Equatorial position. Because equatorial more space is there. Lone pair takes so much space. So we keep on. So you remember those things. Ki suppose one lone pair is there, AB4L, then what is the shape? Suppose 2 lone pairs are there, then what is the shape? Can you tell these shapes quickly? Don't learn it. Try to show it. Ki sir, this was TBP. I put 1 lone pair on equatorial, this shape coming. I put 1 lone pair, 2 lone pair on equatorial, this shape coming. I put this time 3 lone pair, this shape coming. AB12L3. Can you comment on all the shapes? Sir, this one to seesaw. This one what? Seesaw. Arey, seesaw is also known as, you will say, sir, folded square. I have learned everything. Acha, in NCERT, they have also used the word distorted tetrahedron. Correct or not? Bolo. Distorted tetrahedron. ठीक है? Can you tell me some examples? बताओ तो, example बता दो कुछ. SF4. SF4. Can you see in SF4? Correct है? 4 bond, 1 lone pair. 4 bond, 1 lone pair. This one is what? Better to say bent T shape. You remember question came in the paper, T shape, bent T shape, bent T shape. Because exactly it will be not like this. This will also bent. We will see it once again. Example, you can write CLF3. Given in NCERT, CLF3. BRF3. We will see this example. This one, you remember, I3 minus, Xenon F2. All these are same. Now linear. Clear with this? Dekh lo. Can you see it all? So after this chapter, we will take 5 minutes break. Then we will go to the next part. In that time, you can talk to your friends also. Otherwise, you can see also, what taught this thing. In these questions also, from your side, you can do. Ki sir told today 10. I will remember at least 5. I will remember only these 5. So at least 5 things you learned today. See, target of today's lecture is this, something you learn. Your marks increases by something, by attending today's lecture. Then target of this go fire accomplished. So from this class, from every chapter, you have to learn few points which you were not knowing before. Now I will remember it. I will remember it till 4th May at least. 4 May के बाद भूल जाओ, no one cares. But I will remember till NEET. Clear? Okay. So, अरे भाई ये तो किधर लिख दिया? I have written this one in middle. चलो, no problem. Full sequence only changed, bro. Chalo, no problem. Some periodic table things are also there. Okay? So see at least these questions. See at least these questions. Okay. Now see, they are talking about bond. You know some bonding part? Na? Ki sir, I know about overlapping. At least I know about overlapping, sir. What overlapping you know, bhai? Sir, I know. What I know? Sir, positive overlap I know. Acha, theek hai, positive overlap you know. Very good. And what you know? Sir, negative also I know. theek hai. What is positive? Sir, if same sign will overlap, na, then positive. Same sign will overlap, then what? Positive. Same sign will overlap, positive. Acha, if opposite sign will overlap, acha, these signs are not charges. Question came in paper just before yesterday only, I think. Ki this sign, positive, negative are charge. Wrong. If opposite sign overlap, negative. So these are basic things which everyone should know. Sir, I have also heard about one zero overlap. I have also heard about zero overlap. See, how a bond is formed? By head-on or sidewise. Head-on, sigma, sidewise, pi. If you do anything other than this, in which orientation is not correct, you are coming and attaching like this. You are coming and attaching in the middle. These are known as what? Zero overlap. When the orientation is not correct, when the orientation is not correct, these are known as zero overlap. These are known as what? Zero overlap. Clear? So here in this question, they are talking about sigma and pi bond. When sigma bond form, when pi bond form. So if there is head-on sigma, If there is sidewise, pi. So simple concept is there. I will tell you. S orbital always form which bond? Sigma bond. If S orbital is forming bond, it will always form sigma bond. Like see here, 1s sigma, 1s 2px, and here they have taken x-axis as the internuclear axis. So sigma, like this. So S orbital generally forms sigma bond. Generally what means, if it forms sigma only, not pi. Okay? अब देखो, what is the simple logic from which you can do many questions? See, if all are same means sigma. All same means sigma. All same means sigma. Sir, what do you mean by all same? Huh? What is all same? Array, if all the orbitals same and axis also same, px x-axis sigma, py y-axis sigma, pz z-axis sigma. If all same sigma, so this is the slogan, all same sigma, same orbital same axis 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 sigma. So what about same orbital but different axis? Second part, same orbital but different axis means what? Sir, I will take px but I will take y as the internuclear. Acha, by default z is internuclear axis. Sir, I want to take py but z. Sir, I want to take y ले लो या फिर z ले लो, कुछ भी ले लो भाई, x मत लेना, बस सेम नहीं लेने का. I will take sir pz and I will take x axis or y axis. All these case pi. All these case after this. ठीक है? So same sigma, same orbital but axis is different, pi. Acha, if sir orbital are different than 0, nothing can happen by. If py pz perpendicular orbitals you are taking 0, तो तुम बताओ यहाँ पे. Now you tell, can you comment py x axis? जल्दी बताओ. Can you comment on this? This is the question in NCERT कि py and z axis. py and z axis. py and z axis. py and z axis. बोलो. py and z axis. Same orbital but axis is perpendicular, pi. All same, sigma. Orbital same, axis different, pi. Orbital different, 0. Clear? Is it clear to everyone? Now 3 questions we will discuss of MOT. Then we will give you break also. After that we will start with P block and all. Is it okay? देखो भाई, in this break you can see the questions and all. तो चलो जल्दी से these 3 questions which are all based on MOT. So this year we have said कि dipole moment, MOT, from these topics question can come. Dipole moment, MOT, NEET 2025 questions may come from these 2 topics. Everyone should know. अच्छा, MOT we know कि सर molecular orbital theory, ठीक है भाई. You know कि अरे bond order formula I am knowing sir, half NB minus Na. Very good. Bonding electron, anti-bonding electron. If bond order is greater than 0, molecule exists. Molecule exists. If bond order is less than equals to 0, does not exist. See, in NCERT, this one is given for diatomic molecules only. In NCERT, MOT is given for diatomic molecules. So now can you say 4.35 question? Use MOT theory and explain why Be2 molecule does not exist. Batao. What you can guess from these two? They are saying कि why B2 molecule does not exist. सिद्धार्था, चलो बता देते हैं, सुन लो. देखो, one child is asking था shape molecule. See, electron pair geometry. This is the main word. Electron pair geometry. This is the original one. Tetrahedral, octahedral, parent shape, original shape. Tetrahedral, octahedral, parent shape. Electron pair geometry word we use. Next word we use, geometry, shape, structure. Anything they write like this means trigonal, pyramidal, lone pair one. Trigonal, pyramidal. ठीक ना? You write na square, planar. So these things are there. Geometry, shape, structure same. Electron pair geometry different. If they say like this, कि tell me geometry, or they will say tell me geometry, shape, anything, including lone pair. Three types of questions are there, including lone pair. Then these two things are same. Here they have counted lone pair, so original shape will come only. So two parts are there, you can think. If they say electron pair geometry, or they say including lone pair, then original diagrams. If they say only geometry, shape, structure, then without lone pair diagrams. T shape, whatever you are saying, na, T shape, folded square, all those things are coming. Clear? Chalo. So this question we can say कि Bu2 does not exist, that means its bond order will be 0. That's why not existing. Clear? One question done. Okay, so now you know kids, sir, there are two configuration, one configuration for less than equals to 14, one configuration for greater than 14. We know sigma 1s star, sigma 2s star, then pi to px, pi to py, then sigma to pz, then it's pi star orbitals, pi to px star, pi to py star. Clear na? Star. So this. Acha, what is the difference? What is the difference? बताओ तो difference क्या है? What is the difference between less than 14 and greater than 14 case? Less than 14 and greater than 14 case, what is the difference? Difference is only sigma 2pz. Difference is what? बताओ जल्दी. Sigma 2pz. In one case, sigma 2pz is after, and in one case, sigma 2pz is before. In one case, sigma 2pz is after. In one case, sigma 2pz is before. So you can simply say like this. For before 14, na, it is after. And for after 14, it is before. Like this we can remember very easily. For before 14, it is after. And for after 14, it is before. Dekho, before 14 till 14, after. For after 14, before. That's it. Acha. Sir, why this change in configuration is there? Means one time you are writing this, one time you are writing this. So there is one more word you have studied, 2s2p mixing. 2s2p mixing. If we will assume 2s2p mixing, then this case. If no mixing, then this case. So they ask you like this also, in which case, can you tell me in which case 2s2p mixing is taking place? So you have to report the element, means molecule till 14. 2s2p mixing taking place. 2s2p mixing taking place means till 14. 2s2p mixing taking place means till 14. No mixing taking place means after 14. Oxygen, fluorine, like these things. Clear? So many questions they can ask you. They can ask you bond order. They can ask you stability. They can ask you in which case 2s2p mixing taking place. So can you reply? Bolo, which case 2s2p mixing taking place? Less than equals to 14. Example B2C2N2. Okay? Then few more points. Like bond order. Now I will not write the formulas and we will do. We'll directly come to shortcut. Everyone knows the shortcut. Ki 14 electrons are there. Diatomic only we have said 14 electrons are there. Then bond order is 3. That's why I remembered CON2. They are having 14 electrons only. That's why bond order is 3. 15, 16, 17, 18. Batao, bond order decreases by 0.5. If electrons are less, then also bond order decreases by 0.5. Bolo, do you remember this point? We can remember oxygen, everyone knows O2. Oxygen, everyone knows O2, bond order 2. This one you can remember peroxide. Peroxide, do you remember? Peroxide bond order 1, 18 electron. They can write like this also, Na2O2, peroxide. Do you remember superoxide? Superoxide. This is what? Superoxide. Bond order 1.5. So everyone should know oxide, peroxide, superoxide, KO2. It is not necessary. They will give you directly ki O2 minus. Tell me the O2 minus 1. Tell me the bond order. They can give you KO2 is there. Tell me bond order. So you will have to think ki K plus O2 minus. Array, this is the superoxide. Superoxide, count the electron. Achha, many people are applying MOT in other things like phosphate. Bond order they are asking. They are applying MOT. And I am telling you clearly, for diatomic only you apply. NCERT given only for this. Diatomic, diatomic, diatomic. Don't apply MOT beyond diatomic. NCERT not telling. So to avoid mistakes, keep in mind we will apply in diatomic. Phosphate bond order if asked, SO4 sulfate, then that question is different. They can ask you, tell me the bond order in Na2O2. So you know, this is the this is peroxide. So 1. Okay. So now can you tell me bond order of B2C2? Jaldi batao. Can you tell me bond order of B2C2? You can say very easy. Sir, this is very easy. 14 electron, 999, 12 electrons. Sir, 12 electron means 2 bond order. And this one 10 electrons, so sir 1 bond order. Now one point you have to remember everyone, in MOT it is not compulsory कि sigma bond is formed. VBT first sigma then pi. VBT case first sigma and then pi. But in MOT nothing is there. Both can be pi. So in C2 both the bonds are pi. In B2 one bond is there but that is pi. Acha sir, come to this question. I am not able to get this question. Array, this question now very easy. See, 2 questions are there. One this one this one. Very easy. You know bond order is directly proportional to bond strength. You can say stability. Inversely proportional to bond length. Done. So aa jao tum jaldi se. Let's see what do you mean by the term bond order. Calculate the bond order of all these things. See, they have written N2, O2, O2 plus, O2 minus. Can you calculate the bond order? 14 electron, 16 electron, 15 electron, and 17 electron. So 3, 2, 2.5, correct? Huh? And this is 1.5. So now can you compare the stability also? बताओ stability compare कर देगा? So you can tell stability very easily. Sir, stability directly proportional to bond order. So answer is what? A, C, B, D. Done. Bond length order, sir. Bond length order. Bond length order reverse. Bond length order. बताओ. Bond length order reverse. Stability order this. Bond length order will be what? In this case, reverse. Means D, C, D, B, C, A. Is it okay? Everyone can understand this? So this one I am leaving for you as a homework. 36 I am leaving for you as your homework. So everyone see this point. Now we will take some break. ठीक है ना? So we are going to take 7 minutes break. Sir, why 7 minutes break? Huh? How many days are left for NEET exam? Near like this only, na? Chalo, ठीक है. So what is the date today? 25? नहीं, 26. 4, 3, 7. हाँ, almost 7 days. ठीक है? So revise these things. Revise. Whatever we have said. देख लो इसको ध्यान से भाई. देख लो bond order diatomic आएगा. Apply MOT directly. No need to write the configuration and all. Count the electron. Write the bond order. Bond order you know. Stability you know. Bond length you know. 40 question done. 36 you can do on your own. Clear with this point? After this we'll start with P block. Any problem? जाओ भाई तुम भी जाओ. पानी वानी पी लो. आराम से घूम लो. Have some discussions. See the questions which you think. Everyone can mark now. Okay, this 10 question I will remember. This 10 points I will remember anyhow. We have highlighted till now. What we have highlighted? These topics we have highlighted. कहाँ गया भाई पेन? These topics we have highlighted. Electron affinity, dipole moment, MOT, ठीक है ना? And this much only we have done. ठीक है? So these 3 topics everyone should keep in mind. These 3 topics don't miss. ठीक है? तो चलो. So break. We will meet after 7 minutes. What's the time now? 8:41. So 48. चलो wait.
Done. So we are back after 7 minutes of break because NEET exam is after 7 days. Done. So now main chapters understanding base. See, inorganic chemistry, many chapters are there. But the main point of every inorganic chemistry lies in 2 chapters only, periodic and chemical bonding. If you have done periodic and chemical bonding nicely, then most of the things are already done. Most of the things are already done. Periodic and chemical bonding. I am to tell you, keep this in mind. If you want to do good in inorganic, periodic and chemical bonding should be good. Rest all are repetition. Rest all are repetition. Like now we will directly see the questions. Like they are writing, anhydrous AlCl3 is there. Anhydrous AlCl3 is there, and you are bringing this in presence of water, moisture, then white fumes are coming. White fumes are coming. So you know Cl minus from here, H plus from here, HCl gas coming out. HCl gas appears white. Moist HCl appears white. Now see next part. Next part, these two questions are based on inert pair effect. These two questions are based on what? Inert pair effect. Do you know something about inert pair effect? Yes sir, I know. Boron, aluminium, gallium, indium, thallium. Carbon, silicon, germanium, tin, lead. Nitrogen, phosphorus, arsenic, antimony, bismuth. So in these elements, that is n greater than, means from fourth period onwards, do you know the oxidation state of group 13? Plus 3 plus 1 plus 4 plus 2 plus 5 plus 3. So you will say, 2 are possible and their gap is 2 units. Why there is a gap of 2 units? Because we know that their general configuration is NH2, NP1, NP2, NP3. If you add both plus 3, add both plus 4, add both plus 5. So highest oxidation state is sum of NS and NP. Add S and P, highest. Remove S, then you will get the other oxidation state. Remove S, then you will get the other 1, 2, 3. So what they say, ki initial element is stable in plus 3, but the last element in plus 1. Here plus 4, but this one in plus 2. This one in 5, but bismuth is stable in plus 3. So boron to thallium only they are talking. So initial elements will be stable in plus 3, but the last element thallium will be stable in plus 1. So similarly you can do. So can you tell me high oxidation state? Stability of high oxidation state decreases down the group or increases down the group? Stability of high oxidation state decreases down the group or increases? So you will say, sir, clearly visible, decreases. Here plus 3 plus 4 plus 5, very difficult. Acha, this point is opposite in D block. One question came, I will tell you at that time. P block, D block, opposite case. Question came in your face paper. Okay? Next example, तुम बताओ अब BCl3, TlCl3, which will be more stable? Which will be more stable? BCl3, TlCl3. You will say, sir, boron plus 3, oxidation state, no problem. But thallium plus 3, sir, very much problem. Thallium plus 3, very much problem. Boron cannot form BF6 3 minus. Boron cannot form BF6 3 minus. Batao what? Why? I have already told you second period element, covalency cannot be expanded beyond 4. Here, how many covalent bond? Covalency, you remember na? Covalency, friends, total friends, covalency, total friends, 6. But boron can make only 4, second period. So, wrong. Covalency more than 4. Not possible with boron. ठीक है? Okay, next point. Consider the compounds BCl3, CCl4. How they behave with water. BCl3 में पानी डालो, CCl4 में पानी डालो. ठीक है? So this means they are talking about hydrolysis. This means they are talking about hydrolysis. BCl3 simple क्या करने का देखो. BCl3 Cl Cl Cl. You think like this, sir. I will break HOH. HOH. I will do like this. Hydrolysis. So you will get here BOH whole thrice, which is nothing else but boric acid, S3BO3. Sir, I will do the same thing here. No. There is one point written. You remember that point? Ki all tetrahalides of carbon family, tetrachlorides of carbon family undergo hydrolysis except what? No hydrolysis of CCl4. Why no hydrolysis of CCl4? No d orbital. No d orbital. All tetrachlorides undergo hydrolysis except CCl4. Very important. Very important. All tetrachlorides undergo hydrolysis except CCl4. Then you remember in NCERT they have given the example for SiCl4. याद है बताओ. Now silicon is third period element. Third period means 3D present. Third period means 3D present. So hydrolysis possible. Remove Cl and put there OH. Batao, what is the name of this compound? Silicic acid you have written. Silicic acid. So SiCl4 hydrolysis will take place, but CCl4 hydrolysis will not take place. CCl4 hydrolysis will not take place. Correct or not? Will you remember this point or not? CCl4 hydrolysis ledu. No hydrolysis of CCl4. Why? Because there is no d orbital. Clear? BF3 NH4 minus. BF3, everyone knows the shape now. I have already told you. BH4 minus, like BF4 minus. One extra bond is there. BF4 minus BH3. So this is sp3 tetrahedral. This is sp2. So this I have already told you that reaction. Yaad hai? BF3, NH3, change in hybridization, change in shape. So I have already told you that once you study periodic and chemical bonding, most of the points are already done. Batao, will CCl6 2 minus exist? No. Why? Covalency. By carbon 6 bond not possible. Second period more than 4 bond not possible. Aajao. Very important example again. This came in your face paper. याद है तुमको? They asked you how much hydrogen gas liberated. Everyone knows कि भाई aluminium is what? Amphoteric. Aluminium is what? Amphoteric. Means it can react with acid as well as base. With acid, salt formed, hydrogen gas liberated. Base, salt formed, sodium tetrahydroxoaluminate, hydrogen gas liberated. That means with acid or base, hydrogen gas is liberated. They asked you in the paper of Sri Gosalites, face, how much hydrogen liberated? So you think like this, if valency is 1, means what? Monovalent, plus 1 charge. +1 charge monovalent, like sodium, you will see every time. Monovalent means half H2. One positive charge, it will displace one H plus. It will displace one H plus. It will displace one H plus. We'll have to do something for this. Wait once. ठीक है, वन पॉजिटिव चार्ज वन H प्लस मीन्स हाफ H2. बताओ एल्यूमिनियम कितना पॉजिटिव चार्ज है? एल्यूमिनियम 3+. एल्यूमिनियम 3+ मीन्स व्हाट? 3 times H plus. So 3/2 H2. Now in this balance reaction you will find 2 aluminium. 2 aluminium means what? 2 multiply 2. So 2 aluminium means 3 H2. One positive charge, half H2. Like sodium. Sodium displaces half H2. One sodium, half H2. Aluminium 3+. So 3 half H2. 3/2 H2. Here 2 Al used. So now you should know this compound. They will ask you कि aluminium in basic medium you will get tetrahydroxoaluminate. Tetrahydroxoaluminate. Next part, BF3 BF4 minus. Now this is based on back bonding. ठीक है ना? You can ignore this part also. Like we know कि boron is having only 6 electron. It acts as Lewis acid and it has one vacant d orbital. Sorry, it has one vacant p orbital. So fluorine donates its lone pair. So what happens na, in BF3 there is a partial double bond character. BF3 there is a partial double bond character. ध्यान से सुनो. Boron 6 electron only here. 6 electron deficient. Octet not complete, but it is having some space. I am having one p orbital. Please give me electron. Fluorine will give. So pi character starts coming. Pi character. So bond length shorter. But if you will check BF4 minus, 4 bonds formed. 4 bond, only sigma bond is there. Octet complete by 8 electron. Octet complete. Then can you compare the bond length? Batao which bond length is more? This is partial double bond character. This is purely single. देखो they have given the data. BF3 130 picometer, BF4 minus 143. Here only single bond, octet complete, no giving, no taking. But here partial double bond character. ध्यान से देखो, boron 6 electrons only. So fluorine gives the electron, pi character comes, shorter bond. Here single, longer bond. In KFC they give one burger, longer burger. You know, McD and all the giving a spherical circle. ठीक है ना? KFC gives one burger, longer burger. So you can remember BF4 minus, longer bond. चलो. Acha, again you can see the next question. BCl3 dipole moment 0. We have already said कि bond can be polar, delta minus, delta plus. Bond can be polar, but this is a trigonal planar, symmetrical shape. Mu is what? 0. Symmetrical shape, mu is what? 0. Symmetrical shape, mu is what? 0. So bond may be polar. Bond polarity different. Bond may be polar. Molecule will be non-polar. Due to cancelling, symmetry. Okay. One question came in your paper, you remember? कि which of the following has polar as well as non-polar bond? बताओ, याद है तुमको? which of the following has polar as well as non-polar bond? Which of the following has polar as well as non-polar bond? Face paper. So see, simple, polar bond they are asking. Bond means En difference check. Check only En difference, that's it. Same connected. Is there En difference? No, non-polar bond. Here delta minus delta plus, polar bond. So they are just talking about bond. Clear? Bond is different, molecule part is different. Okay? So now let's come to the next part. This question what they are saying, you know, ki AlF3 is there. If AlF3 you dissolve in HF, they are saying what? Ki it is insoluble. It is what? Insoluble. Because we know ki HF is a weak acid. Weak acid. You know HF, HCl, HBr, HI. Who is the stronger acid? HI. It will break. But HF will not break. Difficult to break. You will not get F minus. You will not get F minus. You will not get F minus. No complex form, insoluble. No complex form, insoluble. But NaF or KF, this is what? Ionic. It will break very easily. Na plus and F minus. And finally, there will be a formation of a complex. Have you seen this complex before? Batao. Na3AlF6 cryolite. याद है cryolite group 17. This is written in the ore part. Cryolite. So due to this, it is becoming what? Soluble. Due to this, it is becoming what? Soluble. Due to this, it is becoming what? Soluble. Clear? Then they have written one more point. Ki aluminium trifluoride precipitates out of the resulting solution when gaseous BF3 is passed. Means what? If you are having Na3AlF6 and BF3 you add in this, then they are saying ki again AlF3 will precipitate. How? You know, boron having only 6 electron, it wants electron. So it takes electron from AlF6 and it forms BF4 minus. Then what is left? AlF3 precipitate. What is the conclusion? AlF3, if it will form a complex, it will become soluble. I added in HF not giving F minus, weak acid, no solubility, insoluble. But when I put in NaF ionic compound, Na plus F minus, Na plus F minus, it will form a complex Na3AlF6 soluble. Soluble, happy? Now in this Na3AlF6 solution, they are again putting BF3. Then they are seeing AlF3 precipitated, it becomes again insoluble. Why? Because BF3 deficient, it takes F minus, stronger Lewis acid you can say. It takes F minus. There is one line written in boron family about the Lewis acid character down the group. So BF3 takes F minus. So his F minus gone. Again it becomes AlF3 solid, precipitates out. Are you getting this question? Now this question I think generally we are not discussing, but in your notes it is written. In your notes it is written. Lewis acid character decreases down the group like this. So that point is also very important. Okay. So now there are so many questions. See, size they are talking. We have already discussed that gallium is smaller than aluminium. Size part, radius. Gallium is smaller than aluminium. Oxides very important. Regular question coming on the basis of oxides. Regular question coming on the basis of oxides. Regular question coming on the basis of oxide. Now you know कि what you know भाई कि सर metal oxides ना, metal oxides are basic, non-metal oxides acidic, ठीक है ना? So these things we are knowing. So what in group 13, 14, 15 you should remember group 13, 14, 15 because 16 onwards all are acidic. Very 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 important. Again I am telling you oxides part very 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 important. Oxides part very 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 important. Like boron oxide B2O3, boron, aluminium, gallium, indium, thallium. Boron acidic, non-metal. Middle one amphoteric, last one metal type. Metal type means what? Basic. So this is only written here, indium, thallium are basic. See group 14, two types of oxide formed, one monooxide, one dioxide. You remember CO, CO2. So monooxide, other is dioxide. So we have CO, SiO, GeO, carbon, silicon, germanium, tin, lead. And here we are having SiO2, GeO2, SnO2, PbO2. Clear? Non-metal oxides generally acidic. So these all are acidic. Except, now ये याद है तुमको, some neutral oxides are there. You remember some neutral oxides are there. Some neutral oxides are there. CO. CO is what? Neutral. So initial 3 you can say acidic, rest amphoteric. There is no basic. There is no basic. Acha, one question came in your paper again, face. You remember SiO2 exists at, ye dekho, SiO exists at high temperature. You remember SiO exists at high temperature. Clear or not? SiO exists at high temperature. Clear? SiO exists at high temperature. Done? And then you can go for the next one, that is your 15 group, nitrogen, phosphorus, arsenic, antimony, bismuth. So in initial one acidic, middle one amphoteric, last one basic. So based on this you can do this very easily. So CO is neutral, CO is neutral, these are amphoteric. So very very important, oxide part very 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 important, oxide part very 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 important, oxide part very 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 important. Now you know SiF6, SiCl6. This one also, na? This salt example came in your paper. Both reasons were given there. See, silicon can form 6 bond. Silicon can form 6 bond. No problem. Third period. Now they are saying that fluoride is there, but chloride is not there. Chloride less stable. So they have written fluoride are small. Due to steric reasons, fluoride can be accommodated easily. Small 6 atom. Small 6 atom. Small 6 atom. Can be put easily. But chlorine 6 atom. Big. Difficult. So SiF6 2 minus is possible, but SiCl6 SiCl6 2 minus difficult, big, because it is big. Group 14, what oxidation states can be there? We have already said group 14 means what? Oxidation state are +4 and +2. +4 and +2. +4 and +2. +4 and +2. Okay. Now come to nitrogen family. Can you see this question? Why are pentahalides more covalent? मान लो suppose I am writing nitrogen, phosphorus. PCl5, PCl3. Who is more covalent? You will say PCl5. How you will explain it? Fajan's rule. Fajan's rule. They have told you oxidation state increases. That implies what? Covalent nature increases. Covalent nature increases. Boiling point, ammonia more than pH 3. How? Because there is hydrogen bonding. There is hydrogen bonding. So in hydrides, there are few very important points. You remember? Hydrides of group 15. Hydrides of group 15. Hydrides of group 15. Like you are having NH3, NH3, PH3, ASH3, nitrogen, phosphorus, arsenic, antimony, bismuth. You have to comment on few points. Ki down the group, basic strength down the group decreases. They will ask you about stability. Stability down the group decreases. I am putting the arrow on which side it is increasing. So NH3 more stable, NH3 more basic. Only one point, reducing nature. See, these 3 points very, very, very important. Reducing nature. Reducing nature increases. Can you see this question? 7.2. सबको देखो 7.2. Everyone see 7.2. 7.2. BiS3 is the strongest reducing agent. So reducing nature increases down the group. Reducing nature increases down the group. Reason of all, you can say bond energy. Bond energy decreases. It can be broken easily. Unstable. BiS3 unstable. One more point you can remember, bond angle. Bond angle also decreases down the group. So this is the most important slide now. This is the most important slide now, which can explain many points. Very important, hydride. Why I'm telling you this? Because same points are for group 16 also. Same points are for group 16 also. So if you study one thing, group 16 also done. Same for group 16. Same for group 16. You can say same for group 17 also. Same for group 17 also. So one slide, 3 groups over. So now you tell me, you will remember this or not? One thing is helping you in 3 groups. So you should take some 5 minutes time after this lecture and you should see this. You should see this point. Hydrides, very, very, very important. And properties are same, 15, 16, 17, then to everyone will learn, bhai. Ki one time I will study, it will help you in 3 groups. HCl, HF, HBr, HI, anything they ask, same logic. Clear? This one, same point, repeating again and again. They are asking about ionization energy. Bond energy decreases down the group. So similar points are there. Hydrogen bonding. Thermal stability decreases down the group. So points are similar. Electron gain enthalpy. We know chlorine maximum. Now see here, many points are same. Now this question we can discuss for fluorine, chlorine, bromine, iodine. Fluorine chlorine comparison. Fluorine chlorine comparison. If I ask you bond energy, do you remember the bond energy order? It came in your paper also. Oxidizing nature, fluorine, chlorine, bromine, iodine. Fluorine, chlorine, bromine, iodine. Hydration energy. Small at iron, more hydration energy. Hydration energy inversely proportional to size. Hydration energy inversely proportional to size. Can you tell these things or not? Hydration energy inversely proportional to size. Hydration energy inversely proportional to size. Very, very, very important. This question repetition came in your face exam. Came in your face exam. Bond energy, fluorine bond energy less. Fluorine bond energy less. Noble gases, boiling points are very less because the force is very weak. Weak dispersion force. Weak dispersion force. They have written here no interatomic forces except weak dispersion force. Weak dispersion force. Noble gases, weak dispersion force. So now some angle, bond angle I have told you, bond angle decreases down the group. Bond angle, hydride bond angle. Ammonia, everyone remembers. Ammonia 107. Down the group, bond angle decreases. Down the group, bond angle decreases. Can you tell me this one? See, basic nature. Again, same question coming. Again, same question. I have told you hydride's basic nature. So that slide is very important. This slide very, 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 very important. Basic nature down the group decreases. Thakwa. See here. Same thing asking. Acha, can you tell me R3PO exist? This is very, very simple question. R3PO exist, but R3NO no. Bolo how? Arey 5 bonds. Nitrogen 5 bonds, not possible. Nitrogen 5 bonds, not possible. ठीक है? Last part. Write the reaction for fluorine, chlorine with water. You know reactions are different. See, whatever is different that we should remember. 28th number question, very important. 28th question, very important. Fluorine is an oxidizing agent. It oxidizes water to give O2. Fluorine is an oxidizing agent. It oxidizes water to give O2. फ्लोरीन को पानी में डालो, फ्लोरीन को पानी में डालो, फ्लोरीन ऑक्सीडाइजेस वाटर O2. Chlorine, bromine, normal reaction, HX and HOX. Very important, very important. HX and HOX. Whatever question we have said, if you practice this much only, more concepts will be with you. Acha sir, what about iodine? Iodine, you write reverse of fluorine. See, whatever written here, na, same thing written reverse. O2, O2. H plus, F minus, I minus. Fluorine, iodine, reverse reaction. Because fluorine is oxidizing agent and I minus is a reducing agent. So explanation leave, you just see fluorine, pani, O2. Fluorine, pani, O2. Fluorine, pani, O2. Chlorine, bromine, HX, HOX, HX, HOX, HX, HOX. Clear? Again, these things we have already done. See, bond energy they are asking. Bond energy they are asking. Bond energy they are asking. See, this point. So we have selected some important questions and we have given you. We have selected some important questions and we have given you. Okay? We have selected some important questions and we have given you, out of which you will find the hydrides part repeating again and again. Fluorine chlorine properties, bond energy, ठीक है ना, you can say melting point, boiling point things, oxidizing nature, पानी में डालना, fluorine plus पानी, what you will get? Oxygen. Iodine reaction, opposite. Chlorine bromine, HX HOX, HX HOX, HX HOX. Clear? So that's all. Keep in mind nitrogen and all cannot form more than 4 bonds. So now we will go to the next point, that is DF block. Now see, D and F block is totally understanding topic. ठीक है ना? After teaching also in class, people are facing many problems. So we will highlight few points which came in your paper also. Like everyone knows definition of transition state, transition element, बताओ. Zinc, cadmium, copper, zinc, cadmium, mercury, copper case, copper Ag, Au. These were important or not? So zinc, cadmium, mercury, copernicium, they are not transition element. Everyone knows why. Because D10 in ground state as well as excited state. Ground state as well as excited state. So you will find 3-4 questions are there based on this transition. 3-4 questions are there. Zinc, cadmium, mercury, copernicium are not transition element. Rest D block elements are transition. Clear with this? You know D block element, hard, melting point, boiling point, high, except what? Except again zinc, cadmium, mercury, because they are non-transition. Enthalpy of atomization high. ठीक है ना? Because these all properties are directly proportional to number of unpaired electron. These all properties are directly proportional to number of unpaired electron. These all properties are directly proportional to number of unpaired electron. More unpaired electron, strong bond, strong metallic bond. It will become hard. Melting point, boiling point, high. Enthalpy of atomization, high. ठीक है? Zinc, cadmium, mercury, no unpaired electron. Zinc, cadmium, mercury, no unpaired electron. All these properties are less. Clear? Zinc has minimum enthalpy of atomization in 3D series. Zinc, minimum enthalpy of atomization in 3D series. Minimum enthalpy of atomization in 3D series. Lowest, no unpaired electron. What is the reason? No unpaired electron. So bonding is weak. Acha, can you tell me which elements in 3D series are having single oxidation state? Which element in 3D series have single oxidation state? Scandium and zinc. If they ask you transition element, then scandium. If they ask you D block, then both. Transition element, then scandium. If they ask you D block, then both. Clear? Who is having maximum number of oxidation state? Manganese. 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. Then you remember that order, melting point order, CGS, melting point order, CGS. Maximum melting point in D block. Tungsten. Maximum melting point in D block, tungsten. So about melting point, we have said these things. आ जाओ. This question very important. Suppose you are having Cr plus 2 and Mn3 plus. Can you tell me who will act as oxidizing agent and who will act as reducing agent? Bolo. Who will act as oxidizing agent and who will act as reducing agent? Can you tell this? Who will act as oxidizing agent and who will act as reducing agent? Simple. You will say, sir, chromium to generally present in +3. Chromium generally present in +3. That means this is what? Oxidation. So it will act as reducing agent. It will act as reducing agent. Sir, manganese to generally present in Mn+2. Manganese to generally present in Mn+2. That means this is reduction. So this will act as what? Oxidizing agent. So it will act as what? Oxidizing agent. Solved example NCERT. Solved example NCERT. Then this question came so many times in your paper. You remember? Ma permanganate oxidizing agent. Dichromate is also oxidizing agent. So many times we have used in organic chemistry. But what is the order? What is the order? Don't see the reason. Just see what is the order. It came again and again. Again it can come. So permanganate is a stronger oxidizing agent than dichromate. Permanganate is stronger oxidizing agent than dichromate. Dekho. So all the solved example of NCERT we should focus on. Permanganate is stronger oxidizing agent than dichromate. Ab dekho. This question also very important. Now only you have said कि sir chromium +2 ना reducing agent. Fe2 plus. अब देखो, you know कि अरे chromium +2 तो less stable. It will go in chromium +3. This is oxidation. So it will act as reducing agent. Same point will come here also कि Fe2 plus will go in Fe3 plus because this is D5. This is D3. So this is also oxidation. This will also act as reducing agent. They are asking who is a better reducing agent. Can you tell? Batao. Can you tell who is a better reducing agent? Jaldi bolo, jaldi bolo. NCERT question. All NCERT questions we are picking up. Why the E naught value of this is much more positive as compared to this and this? Okay? So they will ask you later on this also. Ki, this is also reducing. This is also reducing. Who is more reducing? Who is more reducing? Dekho. Which is the stronger reducing agent than Cr2 plus and Fe2 plus and why? So we will solve both the questions. We will solve both the questions. Okay? Batao. So the reason is, first point you have to tell who is more. So we have said Cr+2. Reason you can simply remember like this: more CFSC in aqua complexes. Water complexes means aqua complexes. More CFSC. You have to remember the point, more CFSC. So 2-3 questions on reducing nature are very important. First point we have said is Cr+2 is a reducing agent. Mn+3 is an oxidizing agent. How we have said? We have told you. Next question we have said here both are reducing agent, but who is stronger? Then we have said Cr+2. Cr+2. This question also same. This is acting as oxidizing agent Mn3 plus oxidizing agent, Mn3 plus oxidizing agent, Cr plus 2 reducing agent. Here both reducing agent. Who is stronger reducing agent? Who is stronger reducing agent? Cr plus 2. More CFSE reason you have to give. More CFSE, this reason you have to give. You know fluorine and oxygen. Batao. Fluorine and oxygen stabilize high oxidation states. Why? Fluorine and oxygen stabilize high oxidation state. For oxygen, they have written due to multiple bond, due to multiple bond, due to multiple bond tendency. And they have asked this also, who is better? Who is better? Oxygen is better. Fluorine and oxygen stabilize high oxidation state. And who is better? Oxygen is better. Why oxygen is better? Due to multiple bond formation tendency. Bolo, who is better? Oxygen. Why? Multiple bond tendency. In NCERT about fluorine, they have written bond energy reason and lattice energy reason. Why fluorine complexes in high oxidation stable? Bond energy is high, lattice energy is high. Bond energy is high, lattice energy is high. Clear? Now see, these questions though in atomic structure also you do spin magnetic moment and all. So dekh lo, fluorine and oxygen both can stabilize high oxidation state. Both can stabilize high oxidation state. Who is better? Oxygen. Due to multiple bond. See, this is one of the reaction in preparation of permanganate. This reaction is very important. This is a disproportionation reaction. MnO4 2 minus, green color. Here plus 6. It will be oxidized to permanganate plus 7 and reduced to MnO2 plus 4. This is disproportionation reaction in preparation of permanganate. In preparation of permanganate. So this reaction you should know. Oxidation, reduction. Oxidation, reduction. Is it okay? This question came previous year also. Copper plus 1, copper 2 plus. In aqueous medium. In aqueous medium, who is more stable? Batao. Although this is D10, this is D9. In aqueous medium, bolo who is more stable? Answer is copper 2 plus. Why? Hydration energy. Hydration energy is directly proportional to charge. Have you heard this question? So all these questions might be familiar to you. Correct? This question also came in the paper. This question also came in the paper. Okay? So copper 2 plus high charge, not due to configuration. That's why we are saying aqueous medium. Aqueous medium 2 plus stable due to hydration energy. Hydration energy directly proportional to charge. Why copper plus 1 ion is not stable in aqueous medium? You can say less hydration energy. Less charge, less hydration energy liberated. Less hydration energy liberated. Less hydration energy liberated. Everyone knows, acha, you know this point, cerium plus 4, europium plus 2, terbium plus 4, ytterbium plus 2. What is the main oxidation state of lanthanoid? What is the main oxidation state of lanthanoid? What is the main oxidation state of lanthanoid? Batao. What is the Most stable oxidation state of lanthanoid. Lanthanoid compounds are generally present in which oxidation state? Lanthanoid compounds are generally present in which oxidation state? Lanthanoid compounds are generally present in +3. So they will ask you, out of this, who is behaving as oxidizing agent and who is behaving as reducing agent. So we know Ce+4 is there. It will try to go in +3. Means this is reduction. This is reduction. So this will act as oxidizing agent. Europium +2 will be oxidized to +3. Everyone wants +3. Everyone wants +3. Everyone wants +3, either by oxidation or reduction. So here oxidation. So this will act as reducing agent. So we can conclude if +4 is there, it will act as oxidizing agent. And if +2 is there, then it will act as reducing agent. It will act as reducing agent. This is noble gas configuration. Cerium +4, noble gas configuration, F7, F7, F14. These are already stable, but then also they will go in +3. Then also they will go in +3. Then also they will go in +3. So +4 acting as oxidizing agent, +2 acting as reducing agent. Clear? Acha, lanthanoid contraction we were saying. So lanthanoid contraction is due to, you can say, contraction in size. Contraction in size. You can say regular contraction in size due to poor shielding, or you can say imperfect shielding of 4f electrons. Now this question also came so many times in your paper. Ki what is lanthanoid contraction? Why the sizes of 4D and 5D series elements are similar? Why the sizes of 4D and 5D series elements are similar? Like what they have asked? Zirconium, hafnium, niobium, tantalum, molybdenum, tungsten, palladium, platinum, Ag, Au. These are 4D, these are 5D. Their sizes are similar due to lanthanoid contraction. Due to lanthanoid contraction. Next point you can remember, ki as in lanthanoid, we have lanthanoid contraction. As in lanthanoids, we have lanthanoid contraction. In actinoids, we have actinoid contraction. In actinoids, we have actinoid contraction. So they are asking ki which contraction is more? Batao, which contraction is more? Actinoid contraction is more than lanthanoid. Actinoid contraction due to 5F. Lanthanoid contraction due to 4F. This is poor shielding. This is poorer, worse. So which one is more? Lanthanoid contraction or actinoid contraction? Jaldi bolo. Which one is more? Lanthanoid contraction or actinoid contraction? Actinoid contraction. Which one is more? Lanthanoid or actinoid? Actinoid. Why actinoid is more? Why actinoid is more? Due to poor shielding of 5F. Acha, now see, these are a few theoretical things which you can see. Ki enthalpy atomization is high. I have told you, unpaired electron. Color is due to paramagnetic behavior. Transition element used as catalyst due to variety of oxidation state. Single line questions you can tell. Elements are used as catalyst. Why used as catalyst? Due to variety of oxidation state. Why atomization energy is high? Unpaired electrons are high. Valence electrons are high. Colored complexes. Color is due to unpaired electron. Paramagnetic. Color is due to unpaired electron. Paramagnetic. Interstitial compounds, again features are given, 4 features are given. So these are theoretical questions. At least you can see, I told you now we will do 10 questions, 5 questions, your homework. If you are interested, you should also do something. We will only shout, you will listen, tomorrow you will forget. When you will do on your own something, then you will learn it. If today you will go and check the points of interstitial compounds, you will learn it till NEET. If today you will go and see these questions from the exercise and you will find its solution, which I have said, you will learn it. All things are written in your notes. So these are some theoretical questions which you should do. Then in oxidation part, everyone knows, like suppose dichromate is there. Dichromate, oxidizing agent, oxidizes others and itself reduced to +3. It can oxidize others, I -2, I2, S2 -2, sulfur, Fe2 +2, Fe3 plus. So you have to just remember who is converted into what. Like here they have asked, ki iodide will be converted into what? Iodine. Sulfide will be converted into what? Sulfur. Fe2 plus will be converted into what? Fe3 plus. Main point is these points are same for KMNO4 also. Same for KMNO4 in acidic medium. Same for KMNO4 in acidic medium. You remember this question? If KMNO4 is there and I- is there, basic medium is there, then I- will be oxidized to what? Batao. This question also came in your paper. MnO4- is there, oxidizing agent. I- will be oxidized to what in basic medium? See here, I- oxidized to I2 in acidic medium, no problem, both same. But in basic medium, what will happen? So we have said in basic medium, it is oxidized to iodate. In basic medium, it is oxidized to iodate. This point is important. I- in acidic medium, I2. In basic medium, neutral medium, iodate. IO3-, iodate. Clear with this? Okay. Now again they will ask you same thing for permanganate also. So I have already told you. अच्छा बताओ तो oxalate. This comes in mole concept also ना? जल्दी से बता दो. Oxalate will be oxidized to what? Oxalate carbon +3. Here carbon +4. Oxalate N factor 2. This concept you use many times in mole concept. This concept you use many times in mole concept you have used. ठीक है? तो एक बार देख लो I- I2 in acidic medium, IO3- in basic medium or neutral medium. In basic medium or neutral medium. Okay? This they are talking about color. बताओ color के लिए क्या था? What is required for colored compound? Paramagnetic, unpaired electron. So write the configuration and check who is having unpaired electron. Like Sc3 plus, noble gas configuration, colorless. Titanium 4 plus, noble gas configuration, colorless. Zinc 2 plus, D10 configuration, colorless. Colorless. No unpaired electron. Colorless. Generally, they will ask you these ions only. Copper +1. Lo bhai, copper +1. D10 configuration. Copper +1. D10 configuration, colorless. Titanium 4 plus colorless. Clear? Okay. So these compounds you can do inner transition. F block. Who is F block? 102. I have given you the starting and ending. I have given you the starting and ending. I have given you starting and ending. Last element of actinoid. Batao. Who is the last element of actinoid? Who is the last element of actinoid? Lawrencium. Configuration you can check once from NCERT. Okay? Done. So this is about D and F block. So D and F block mainly we have seen 2-3 points. Cr plus 2 is a reducing agent. Mn plus 3 is an oxidizing agent. Cr plus 2 Fe2 plus both reducing. Who is better? Cr2 plus. We have seen oxidizing agent order permanganate more than dichromate more than VO2 plus 1. Okay? Some reactions of permanganate also we have seen. So now we are finally moving towards the next chapter, that is your coordination compound. What are the important points in coordination compound? You can say Werner's theory you should study, hybridization finding and all you should check once, and then isomerism also you can check. Isomerism also plenty of questions they are asking. Isomerism also plenty of questions they are asking. Like Werner's theory, they ask you moles of AgCl precipitated. Like see, if there is a formula like this, CO. A few points I am telling you about oxidation state. Like cobalt plus 3 is there, na? Then coordination number is 6. This you can remember. Palladium plus 2 is there or platinum plus 2 is there. Then coordination number is 4. Palladium plus 4 is there. Platinum plus 4 is there. Then coordination number is 6. These 3 things you can remember. Based on this, how I will tell you moles of AgCl precipitated. They will ask you about conductivity. They will ask you about conductivity. Primary valency, secondary valency they can ask. Like see the third part. PtCl4.2HCl. Can you see it? This compound is also written as H2PtCl6. H2PtCl6. Both are same. Check करो ऑक्सीडेशन स्टेट ऑफ प्लैटिनम +4. ध्यान से देखो. चेक ऑक्सीडेशन स्टेट ऑफ प्लैटिनम +4. Check oxidation state of platinum +4. +4, what oxidation state we have said? Coordination number we have said 6. देखो यहाँ पे +4, coordination number 6. You can see here, yes sir, correct. Now if I will ask you moles of AgCl, देखो NeCl is outside the coordination sphere. How you get moles of AgCl? If Cl minus is outside, that will be precipitated. Are you having any moles of Cl minus here outside this sphere? No. That means moles of AgCl 0. That means moles of AgCl 0. Then you will ask, sir, how to tell primary valency and secondary valency? You can say primary valency is equal to oxidation state and secondary valency is equals to coordination number. Simple, you can tell from oxidation state and coordination number. Bas khatam. Oxidation state and coordination number. Like what is the coordination number of platinum? Coordination number I told you. How many sigma bond? Bolo, how many sigma bonds are there? 6. So coordination number is 6. What is the oxidation state of platinum? You have said 4. So primary valency is 4. Tell primary valency always from oxidation state. Tell primary valency always from oxidation state. Tell primary valency always from oxidation state. Like see, they will give you compound like this, COCl3.6NH3. You have to tell moles of AgCl, primary valency, secondary valency, all. I will give you 2 compounds in fact. Dekho. So first of all, you'll have to see like this, cobalt plus 3, cobalt plus 3. Means coordination number is, how much coordination number? 6. Coordination number is how much? 6. So first you take 6 things inside. Like first you take the neutral part inside. First you take neutral part inside. 6 done. Coordination number 6. What is left? Cl3. हो गया? Here what? Here also I will do the same thing. Cobalt. I will take 5 NH3 inside. ध्यान से देखो इधर. I will take 5 NH3 inside. I will take 5 NH3 inside. Coordination number तो 6 ना? So take one Cl also. How many Cl left? Cl2. So can everyone write the formula like this? ध्यान से बताओ. Can everyone write the formula like this? Yes? Okay. Now, moles of AgCl precipitated. For 1 mole of this compound, 3 Cl are outside. So thrice. Here, how many Cl are outside? Twice. They will ask you cation is to anion ratio. Like when you will break this compound, which ions you will get? CONH3 6 cross multiply 3 plus, and you will get Cl minus. How many times? 3 times. So total how many ions you are getting? 4 ions. They will ask you electrolyte ratio. Electrolyte ratio means what? Cation is to anion. Electrolyte ratio means what? Cation is to anion. Can you tell here how many ions are there? You will say, sir, simple. 2 ions of chloride and 1 big. So 3 ions. Total how many ions? 3 ions. Can you tell electrolyte ratio? Batao. Can you tell electrolyte ratio? Yes, sir. Cation 1, anion 2. 1:2. If I ask you conductivity, can you tell me conductivity of these 2 compounds? Can you compare conductivity of these 2 compounds? 1 more than 2. Why? Conductivity is directly proportional to ions. Conductivity is directly proportional to ions. Number of ions. So you will say 1 more than 2. Here 4 ions. Here 3 ions. So can you all tell now how to tell moles of AgCl precipitated? Can we compare the conductivity of a compound? Yes or no? Can we compare conductivity of a compound? Yes or no? Chalo, I am giving you next question. मान लो suppose they are giving you platinum Cl4 dot 4NH3. चलो बताओ. Here you have to tell number of moles of AgCl. So you will say, sir, platinum plus 4. Platinum plus 4 means coordination number 6. Correct? I have told you already. Plus 4 means coordination number 6. Plus 2 means coordination number 4. So plus 4 means coordination number 6. How I will write 6? I will take 4 ammonia inside. And what? 2 Cl inside. Bolo. Then how many Cl left? 2. So double. So you can say moles of AgCl precipitated is what? 2. Acha, can you tell me primary and secondary valency in both the case? Primary and secondary valency. Secondary valency 6. Can you tell me primary valency? Primary valency. ध्यान से सुनो, जल्दी देखो इधर. Can you tell primary valency in both the case? Is it same or different? 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 Now many people do mistake here. ध्यान से देखो, many people do mistake here. They will say primary valency sir here 3, here 2. Bolo, you do like this or not? Primary valency 3, primary valency 2. Wrong. Both case primary valency 3. I have told you before only, primary valency you have to tell from oxidation state. Primary valency you have to tell from oxidation state. Primary valency you have to tell from oxidation state. Some nomenclatures also you can practice. Primary valency you have to tell from oxidation state. आ जाओ next. So we have said कि 3 points are important. Werner theory, basic points I have told you. Hybridization, isomerism. Let's come to isomerism. Isomerism, now it can be divided into 2 parts, structural and stereo. Structural is very easy, so we can do. Like what? You know there is ionization isomerism, there is solvate isomerism, there is linkage isomerism, and there is coordination isomerism. Linkage very easy. How you identify linkage isomerism? Batao. How you identify linkage isomerism? Batao. You will simply say, sir, I want ambident ligand. क्या चाहिए बताओ तुमको? Ambident ligand. Ambidentate ligand. What do you mean by ambidentate ligand? Which can donate from both sides. Cn minus. Cn minus means what? It can give from C. If you write Nc minus, it can give from N. So if these type of ligands are there, Cn minus, NO2 minus, SCN minus, these are what? These are ambidentate ligand. These are what? Ambidentate ligand. So they will show which isomerism? Linkage. They will show which isomerism? Linkage. Acha, coordination isomerism. Generally, if both parts are complex, means what? See, first part is known as cationic part. Second part is known as anionic part. If cationic part is also complex, anionic part is also complex, then there is chance of coordination isomerism. Confirm you can see and tell. Because in rest case, it is not compulsory कि both parts are complex. Here, both parts are complex. ध्यान से देखो, cationic part also complex, anionic part also complex. Then I can tell coordination isomerism. Acha sir, what about ionization? See, if you have a compound like CONS3 whole 5, Cl is here and Br is here. Now we know this is coordination sphere. And this is what? ionization sphere. So I will write one more compound, CONH3 whole 5. I will put Br inside and I will put Cl outside. I will put Br inside and Cl outside. So if there is exchange between coordination sphere and ionization sphere, then that is known as ionization isomerism. That is known as what? Ionization. Sir, then what is solvate? Solvate, same thing. Here also exchange taking place, but exchange is taking place for water or the solvent. Exchange is taking place for water or the solvent. Like this compound is there, and the other compound I am taking one water outside. ध्यान से देखो, one water I have taken outside. Less space is there. See this one once, I am writing it here. One water I am taking outside and Br I am bringing inside. Like this. So here also exchange taking place, but solvent is getting exchanged. So you can easily say this is solvate. So ionization and solvate similar. Exchange. If water solvent is exchanged, then solvate. Ambident at ligand present, linkage. Both parts are complex, coordination. Both parts are complex, then what you will say? Coordination. Both parts are complex, then what you will say? Coordination. Now see which question you can solve based on this. Identify karo yahan se. Like third one, can you see the third option? They are asking which isomerism can be here. You are having NO2. What you are having? NO2. Means you can say linkage is possible, sir. What you can say? Linkage is possible, sir. Ambident ligand linkage. Ambident ligand linkage. Acha, what can be possible here? Batao, what is the relation between these two? What is the relation between these two? Can you tell? What is the relation between these two? You will say, Kya both looking similar, only exchange is there. Coordination sphere and ionization sphere exchanged. Bolo, Cl went outside and SO4 came inside. This is the change or not? Cl went outside, SO4 came inside. So this is an example of ionization isomerism. This is an example of ionization isomerism. This is an example of ionization isomerism. Here they are asking you ki how you can differentiate between them. How you can differentiate between them. Like see, if you are having this compound, then here you will get sulfate ion. So this will give the test with BaCl2. BaSO4 white precipitate will be formed. BaSO4 white precipitate will be formed. With AgNO3, no reaction. With AgNO3, no reaction. Because Cl minus is not outside, na? Because Cl minus is not outside. Cl minus is inside. So you will not get Cl minus. So AgNO3, no AgCl precipitate. But if you will put BaCl2, you will get BaSO4 precipitate. You will get BaSO4 precipitate. Sir, what about the second one? Second one, dekh lo. If I put sulfate inside and chloride outside, batao, this will give AgNO3 test or AgCl precipitate or not? Yes. Sir, what will happen with BaCl2? No reaction. No precipitate of BaSO4 because sulfate is not outside. Because sulfate is not outside. Because sulfate is not outside. So this is about structural isomerism. Exchange between coordination and ionization, ionization isomerism. ठीक है? Water exchange, solvent exchange, solvate. Ambidentate ligand, linkage. Both part complex, coordination. Bolo, is it clear? Sir, tell something also about stereo. Now see, stereo part is difficult. Stereo part is difficult. See, in stereo part, few points you can remember. Like tetrahedral complexes does not show GI. Square planar complexes don't show optical isomerism. NCERT question is also there. Ki why tetrahedral complexes don't show geometrical isomerism? Dekho. Why geometrical isomerism is not present in tetrahedral complexes? You will have to say कि sir relative positions are same. Means what? मान लो suppose this is metal A, B, C, D. All the bonds are same. All the angles are also same. So relative position is same. Relation is only one relation. So reason is as relative position. देख लो सॉल्यूशन में क्या है. Relative position of ligands are same. As relative position of ligands are same. Clear? Now few compounds you can remember directly. Like Ma3B3 is there. Ma3B3, then 2GI. Which 2GI? We remember face and mer. Face and mer. Who will show face and mer isomerism? Ma3B3. Who will show face and mer isomerism? Ma3B3. देखो ये. Can you tell me which isomerism will be shown by this compound? CONS3 whole thrice Cl3. Bolo, which isomerism? Ma3B3. Face mer 2GI. Now two more compounds are there. Ma2B2 also 2GI. Ma4B2 2GI. In this only there is example cisplatin used in cancer treatment, tumor treatment. Cisplatin. You know the formula of cisplatin? बताओ cisplatin का formula पता है? Cisplatin formula. Cisplatin. This is the diagram of cisplatin. Platinum, ammonia, chlorine. Cis form is known as cisplatin. Used in tumor treatment, cisplatin. You can clearly see Ma2B2. A2B2. Next compound, you can remember two compounds at least, MAA whole twice A2 and MAA whole thrice. That's it. Here two forms are there, cis and trans. Out of which cis is optically active, trans is inactive. Cis is active, trans is inactive. Cis is active, trans is inactive. Cis is active, trans is inactive. Now let's do question. Acha, here what you will say? In the last one you can say no GI, but there are two optical isomers. So now let's see this question. Can you see this? COEN whole thrice Cl3. This compound is looking like what? COEN whole thrice. AA is a didentate ligand. AA is a didentate ligand. So can you see same thing or not? देखो यहाँ पे AA whole thrice means how many optical isomers? 2 optical isomers you can say. AA whole thrice, 2 optical isomers. Can you see this formula? Oxalate. Again, oxalate is a didentate ligand. Again, oxalate is a didentate ligand. देखो AA2 A2 AA2 A2 AA2 A2 cis form is there and trans form is there. Cis form is there and trans form is there. Which is optically active? Cis form. They will ask you question which of the following compound is optically active, and one of the option will be cis KCrH2O whole twice C2O4 whole twice. This will be there. So you will have to identify this is AA2 A2. So cis and trans. Cis active. Cis active. Now last part, that is your hybridization. 3 things we have to see. Hybridization, 3-4 compounds you have to keep in mind. Very important. NiCO4. NiCO4. Do you know hybridization of this? sp3. sp3 is there, that means tetrahedral. Now this people don't remember. You can solve it, but directly remember also. So many times it is coming. Acha, next thing, people think sp3 tetrahedral means what? It will be paramagnetic. No, this is diamagnetic. This is diamagnetic. 4 examples only I will tell you, and you can directly learn examples. Platinum complexes are there. Platinum +2 +2. Palladium. You know what is the coordination number? 4. It is always DsP2. Irrespective of ligand, it is always DsP2 square planar. It is always DsP2 square planar. If you have platinum +2 +4 and palladium +4, coordination number 6, it is always D2sp3 octahedral. Irrespective of ligand, very important point. You take weak fill ligand or strong fill ligand. Platinum in 2+, coordination number 4, inner orbital complex. Very important. इसको दिमाग में बैठा लो. Keep this in your mind. Don't forget. Only 3-4 things I am telling you in hybridization. NiCO4, learn it. sp3 tetrahedral, diamagnetic. And platinum palladium 4d 5d series elements. Other elements are also there, but they are asking generally platinum palladium. Always inner orbital complex. DsP2 means square planar. D2sp3 means octahedral. You can see these examples now. Acha, strength of ligand, you should remember the order. Dekho, NiCO4 in text example. NiCO4 is diamagnetic. Can you see it? NiCO4 is diamagnetic. I have written. Can you see this example? Platinum CN4. Although here a strong fill ligand, but if I write here weak fill ligand also, hybridization will not change. Keep in mind, hybridization will not change. Cyanide or chloride. Weak fill ligand or strong fill ligand. Palladium, platinum. Inner orbital complex. Keep this in mind. And all these are the questions of NCERT. All these are in NCERT. One more you can remember. कौन सा बताओ? You remember cobalt. Cobalt 3 plus. You remember cobalt 3 plus. Water and oxalate. They behave as strong fill ligand. Strong fill ligand D2sp3. So these 4 examples only in hybridization. If you just remember these 4 examples, chances are there कि question may come from here only, and you can solve it very easily. NiCO4, palladium, platinum, cobalt with H2OX, that is behaving as a strong fill ligand. Hybridization is D2sp3. Hybridization is D2sp3. मत भूलना, cobalt with oxalate. We can find examples based on this, cobalt and oxalate. Okay. See, they are asking question, how many ions are there? You can see the application part once on your own. Application also, coordination compound, D and F block. Application is also important. Coordination compound, D and F block. Application is also important. Application part very important. So many things written here. We have already written in our notes. Now see, this question comes again and again in your paper. Face paper, 2-3 times we have asked this question. Wavelength wala, yaad hai ki nahi? Wavelength 1. 3 examples of NCERT. 3 examples. Directly do this. Very, very, very important. This we have asked you so many times in the paper. Stability based on chelation, ring. Oxalate is a didentate ligand. It will form ring, more stable. So these 3 questions you can check once nicely. Okay. Then we will finally move towards the last part, that is your biomolecules. Biomolecules now everyone is knowing because the same parts are there in bio also. We will mainly see reducing sugar. What you should study in this, reducing sugar. Reducing sugar, you know, which will give tolerance, Felling's solution, Benedict. These tests given means reducing sugar. Who will give monosaccharide? Acha, before this we know that tolerance test is given by aldehyde. Glucose is having aldehydic group, so it will give no problem. Fructose is having ketone. Fructose is having ketone. Then how fructose is giving or not? So fructose also, keep this in mind, fructose, all monosaccharide. And you can say disaccharide also. But except what? Except sucrose. We asked you this, except sucrose. Except sucrose. Clear? Second part, you should know all the monomers of disaccharides. Everyone should know monomers of disaccharide and their linkage. Like see, they have asked here, what are the expected products of hydrolysis of lactose? Now you know lactose is a disaccharide. It is a disaccharide of what? Beta D galactose. And what? Beta D glucose. 1,4 linkage. Both beta link. One question came in your paper, you remember? They have asked lactose only, but they have written here there is alpha linkage. Before few days only, there is alpha linkage between beta D galactose and beta D glucose. There is alpha linkage. Wrong. Beta linkage. C1 C4. Most of the cases C1 C4 linkage is there. This question, how do you explain absence of aldehydic group in pentacetate of D-glucose? How you are rejecting open chain structure? open chain, proof for, you can say proof for absence of CHO group. 3 reactions, 4 reactions given in NCERT. Very, very, very important. They will ask you this only. Very, very, very important. Which reactions are not given? Batao. Shift test, not given. 2,4-DNP is not given in NCERT, but it is very important. 2,4-DNP is also not given. Addition of NaHSO3, not given by glucose. Not given by glucose. These 3 reactions not given by glucose. Which reactions are not given by glucose? Addition of sodium hydrogen sulfate, Schiff reagent and 2,4-DNP. These 3 reactions not given by glucose. From which we conclude that CHO group, free CHO group is absent. Something is happening there. Fishy, something fishy. Then one more part is there. If you have a pentaacetate and you react with hydroxylamine, no reaction. See, glucose reacts with hydroxylamine. ध्यान से सुनो. Glucose reacts with hydroxylamine, but pentaacetate of glucose does not react. So here you will say here pentaacetate of glucose does not react with hydroxylamine. So we can conclude ki open chain structure there is some problem. Free CHO group is not present. See, this question is also in NCERT, but many people ignore it. Dekh lena. Reducing sugar, I have already told you. Can you identify who are monosaccharide, who are disaccharides? Yes. Hydrolysis product, lactose, we have already said. See, this is now 2 times in NCERT only. 2 times in NCERT. Do you remember the reactions with HI? What you will get? N-hexane, bromine water, mild oxidizing agent, gluconic acid. It confirms the presence of aldehyde. It confirms the presence of aldehyde. 5 reactions are written in the beginning. Same 5 reactions we have asked you in the paper also. Same 5 reactions we have asked you in the paper also. So you should know the product and you should also know the conclusion. Ki what is concluded? Like from HI, it is concluded ki there is a straight 6-carbon chain. From bromine water, it is concluded that there is aldehyde group present. From HNO3, it is concluded that primary alcohol is present. Terminal alcohol, one primary alcohol is present. This, what is the product with HNO3? Saccharic acid or glucaric acid. Saccharic acid or glucaric acid. Enumerate the reaction D-glucose which cannot explain the open chain structure. देखो यहाँ बता दिया. Which reactions are not given? This you can write it there. Essential, non-essential amino acids we are knowing. They have told you shortcut tricks also, so you can remember few shortcut tricks. Amphoteric nature. देखो, you know amino acid, you can write amino acid. Now in solution, it remains in form of salt. They have written in NCERT कि in aqueous medium it behaves as a salt. How salt? This will give H plus, this will take H plus. So it will remain as this. This is only known as Zwitter ion. You know, this is known as Zwitter ion. Now Zwitter ion is amphoteric. Zwitter ion is amphoteric. Zwitter ion is amphoteric. Clear? Zwitter ion is amphoteric. Now amphoteric means what? It can react with acid as well as base. It can react with acid as well as base. So when you will put H plus, ध्यान से सुनो, when you will put H plus, then who will react? Batao, I am writing it once again. Suppose this is the Zwitter ion. I add H plus in this and I add OH minus in this. I am saying that this is amphoteric. So it can react with acid also, it can react with base also. Ab batao, who will react? You will say, sir, very simple, plus minus jod do. So this H plus will combine here. So you will get a cation, sir. This is the product. You are getting a cation. Acha, what will happen when I will put OH minus? Very simple, sir. OH minus will take H plus. This will to not connect na. Minus minus, bolo, same charge. Will they connect? No. OH minus will take H plus. So you will get what? This one. So you are getting an anion. So what you see from here? Ki it is reacting with acid also, it is reacting with base also. That's why it is amphoteric. Now denaturation, vitamins and all you have seen in bio also. ध्यान से देख लेना, vitamin K increased blood clotting. This is in NCERT exercise. So vitamin K you have to know the names also. B1 thymine, B2 riboflavin, B6 pyridoxine, ascorbic acid. They ask one question in a paper like this, which of the following acid is a vitamin? Which of the following acid is a vitamin? Which of the following acid is a vitamin? And options they are giving: formic acid, ethanoic acid, butanoic acid, ascorbic acid. People will think, "Arey, all are to acid only." Then who is vitamin, bhai? Ascorbic acid is vitamin C. From childhood we are studying scurvy, vitamin D, rickets, vitamin E, RBC will rupture, increased fragility of these are disease caused due to deficiency. Pernicious anemia, this is most commonly asked. Vitamin B12, cyanocobalamin, cobalt is the metal. This also comes in coordination compound. Yaad hai? Pernicious anemia B12, pernicious anemia B12, convulsions B6, convulsions B6, blood clotting time increased, vitamin K. This you have studied in bio. So many things you have studied in bio also. So this is all. Okay. Now salt part, if you want to see salt part, I will tell you in salt part there are generally three tables you should see. So in last 10 minutes we will quickly see this salt part. We will quickly see this salt part. Tables are there. This table you should see. Three tables mainly you should see. Based on that only we have also asked the questions. Three tables are there: preliminary test, confirmatory test, and finally cation part. This was also taught to you before, like cation. So this we can do on the basis of the question which came in the paper, face papers you have given na. So see, one question came like this: ki Pb2 plus, Fe3 plus, copper 2 plus, calcium 2 plus, and reagents they were asking you to match. So this question can be easily done if you remember this table. What is the reagent in every case? What is the reagent in every case? Cationic reagents. Last year only we teach so much in salt to be on the safer side. But what they asked in the paper, they just asked this, ki who is group 2, who is group 3 type of things. So this time you can remember the reagents. Ki what are the reagents of different group? We have asked in face paper. See, the next question, again we have asked the same thing in the face paper. We are asking you again same and same. Then also you are doing wrong, which you should not do. You should not do it. Ab dekho, few more reactions we have asked you, like okay, some reactions. So these I have taken some questions from our face paper only. So face paper, very important papers. So you can take out some question from there, and same questions you can practice again and again, again and again, again and again. ठीक है ना? And 3 tables are there, preliminary tables are there which you can do. Preliminary tables are there which you can do. Like they will ask you कि Cl minus is there, H2SO4 is there. Will you get Cl2? Br minus is there, H2SO4 is there. Will you get concentrated? I am talking. Will you get Br2? I minus is there and concentrated H2SO4 is there. Will you get I2? Which reaction is wrong? You should tell very quickly, sir, this reaction wrong. Cl minus oxidation is difficult. You will get here HCl, not Cl2. Bromine color, reddish brown, everyone knows, reddish brown. I2 color, violet. I2 color, violet. Br minus and I minus can be confirmed by layers test. Can be confirmed by layers test. What is the test for Cl minus? You have studied, chromyl chloride was there. Do you remember chromyl chloride? H2SO4 with dichromate, Cr2O7 minus. What is formed? Red vapors. What is formed? Red vapors of chromyl chloride. Red vapors of chromyl chloride. Do you know NH4 plus? NH4 plus reacts with Nessler's reagent. Nessler's reagent. Spelling you can check once. Nessler's reagent. Who cares about the spelling? Formula is important. We are not studying English. K2HgI4. K2HgI4. We are studying chemistry. K2HgI4. Nessler's test is given. Nessler's reaction is given. You will say ammonium ion is there. Now, based on this only, we asked one question in the face paper. They were writing like this: Nessler's reagent, it has reacted, and with dichromate, it is giving reddish vapors. So the answer was NH4Cl. How you confirm? Nessler's given means NH4 plus. Dichromate, H2SO4, red vapors means chromyl chloride. Chromyl chloride. So based on this, we can tell NH4 plus Cl minus. Clear with this? So many things are there. So those tables only I will say you, कि those tables confirm which gas is liberated in which case. Like if I will give you, ठीक है ना, कि मान लो, can you tell which gases are liberated? CO3 2 minus, SO3 2 minus. I will put here dilute H2SO4. Which gas liberated? You will say CO2. Here which gas liberated? SO2. Both turns lime water milky. Both turns lime water milky. Both turns lime water milky. Then how you can differentiate? How you can differentiate? You can say, sir, this one +4, highest oxidation state. This one +4, medium oxidation state. One question came in your paper, that this acts as a reducing agent. So if you will put dichromate here, Cr2O7 minus, you will get green color. But here no reaction will be given. Here no reaction will be given. From this we can confirm it was not carbonate, it was sulfite. It was not carbonate, it was sulfite. Acetate I can do very easily. Arey sir, vinegar, this is nothing else but what? Vinegar, sweet smelling. Sweet smelling with what? If I will take any alcohol, it will form ester. So like these things are there. So I will suggest you, so many slides we have written. I will suggest you you see the tables in salt. Tables in salt. Only the tables first. Then whichever is your favorite color, read that reaction. whichever, like yellow is your favorite color, see the chromate part. ठीक है, your choice. Reaction, your choice, because at last moment we cannot remember all the reactions. So read the tables first, preliminary test, confirmatory test, table, cation table, and then reactions of your choice. ठीक है, so that's all about today. So many slides are there. If you want to share it, you can take it and at least revise these questions. At least revise these questions. Target is to improve our marks. If you learn something from this 3-hour class, that means what? Target accomplished. Last few days are there only. You should at least go through these questions, because these questions are NCERT questions only. We are not giving any hypothetical. NCERT is very important for NEET exam. So NCERT questions only we have discussed. So now you can take your time. If you have marked the questions, you can go and check those questions, whichever points we have said. Okay? So chalo, that's all. Bhai, let the QR code come. So hope you have understood something. You will have to see it once again, because it is very difficult to digest everything in 3 hours. Okay, na? So we have highlighted once. Today you have to read this organic. Today if I have taught you 3 hours, at least you should also give 3 hours. Okay, na? And you should see the questions which we have said. Aluminium reaction with acid and base, very important. 3H2 liberated for 2 aluminiums. Okay? So many pages are there, na? So it is taking so much time to generate the QR code also, I think. Chalo, theek hai. Thanks everyone. Bye bye.